Imagine a universe where the very fabric of reality is shaped by something we can't see, something that's everywhere but completely invisible. It bends the motion of galaxies, warps the structure of space itself, and yet, for decades, it has remained one of the biggest unsolved mysteries in physics. Scientists call it dark matter, and for years, they've been trying to figure out what it actually is. But there's one theory that's been gaining attention, a theory that could completely change how we understand the universe. It's called fuzzy dark matter. And it's weird. Really weird. For the longest time, scientists thought dark matter was made up of heavy, slow-moving particles, kind of like invisible marbles floating around in space. That idea made sense because it helped explain why galaxies spin the way they do. If you look at a galaxy, you'd expect the stars on the outer edges to move slower than the ones near the center, just like how planets in the solar system orbit the sun at different speeds. But that's not what happens. Instead, the stars on the outskirts of galaxies move just as fast as the ones near the center. It's like something invisible is holding everything together, adding extra gravity where there shouldn't be any. That's where the idea of dark matter came from. Scientists figured there had to be some kind of invisible substance creating this extra pull. But what if dark matter isn't made of heavy particles at all? What if it's something completely different? That's where fuzzy dark matter comes in. Instead of being made of small, hard particles like marbles, fuzzy dark matter is made of ultralight particles that behave more like waves. These particles are so light, and their wavelengths are so large, that they don't act like normal matter at all. Instead of clumping together into small, dense regions, they spread out into giant, wave-like structures that ripple across space. And this is where things get really strange. If fuzzy dark matter is real, then space itself might not be as solid as we think. Instead of galaxies being surrounded by invisible particles of dark matter, they could be surrounded by massive, quantum wave-like structures that shift and change over time. This could explain some of the weird things astronomers have been observing, like the strange, ghostly halos around galaxies, or the unexplained motions of certain stars. It could even change how we think about black holes, the Big Bang, and the very structure of the universe. But before we go too deep into the implications, let's break down what makes fuzzy dark matter so different from other dark matter theories. The key is in the size of the particles. Regular dark matter models assume the particles are heavy, much heavier than protons or electrons. These heavy particles move slowly and behave pretty much like regular matter, except they don't interact with light. That's why they're called dark. But fuzzy dark matter is made of particles that are so incredibly light, possibly around 1 billion times lighter than an electron, that they behave in an entirely different way. Their wavelengths are so large that instead of behaving like individual particles, they act like waves. And because of quantum mechanics, these waves don't just sit still. They spread out, interfere with each other, and create strange, shifting patterns across space. One of the biggest consequences of this is that fuzzy dark matter wouldn't clump together the way regular dark matter does. Instead of forming small, dense structures, it would create vast, smooth halos around galaxies, halos that could be constantly shifting and changing over time. This might explain why some galaxies appear to have strange, blurry edges instead of sharp, well-defined boundaries. It might also explain why certain small galaxies seem to be missing dark matter entirely. If dark matter is actually a giant wave-like field instead of a collection of tiny particles, then its distribution across the universe might not be as uniform as we thought. Another mind-blowing thing about fuzzy dark matter is how it interacts with black holes. In traditional dark matter models, black holes simply absorb dark matter like they do with any other kind of matter. But with fuzzy dark matter, the story gets a lot weirder. Since it behaves like a wave, it doesn't just fall straight into black holes. Instead, it can create interference patterns that affect how matter falls in and how energy is released. Some scientists think this could explain some of the unusual signals we've detected from black holes, like strange flickering patterns in X-ray emissions that don't match what we'd expect from regular matter. But here's where things get even crazier. If fuzzy dark matter is real, then the universe itself might have a kind of quantum fuzziness on a cosmic scale. Think about it. Quantum mechanics usually only applies to things that are really, really small, like atoms and subatomic particles. But if dark matter is made of these ultralight, wave-like particles, then quantum effects wouldn't just be happening on tiny scales. They'd be happening across entire galaxies. That means the universe we see, the one that looks stable and structured, might actually be shifting and changing in ways we can't even detect. Now, you might be wondering, if fuzzy dark matter is such a good explanation for all these weird cosmic phenomena, why isn't it the leading theory? Well, the truth is, we don't have solid proof yet. Scientists are still trying to figure out whether the properties of fuzzy dark matter match up with what we see in the real universe. There have been some promising clues, though. For example, studies of ancient galaxies, ones that formed billions of years ago, show structures that seem to match what we'd expect if fuzzy dark matter were real. Computer simulations have also shown that this kind of dark matter could create the large-scale cosmic structures we observe today, like massive galaxy clusters and cosmic filaments. But there's still a lot of work to do before we can say for sure. One of the biggest challenges is finding a way to test the theory. Since fuzzy dark matter doesn't interact with light or normal matter in a direct way, it's incredibly hard to detect. Scientists are looking for indirect clues, things like the way galaxies rotate, the way stars move, and even subtle effects in the cosmic microwave background, the faint radiation left over from the Big Bang. Some researchers are also exploring the idea that fuzzy dark matter could create interference patterns in gravitational waves, ripples in space-time caused by massive cosmic events. If we could detect those patterns, it might give us a way to confirm that this strange, wave-like dark matter actually exists. But even if fuzzy dark matter turns out to be real, it raises even more questions than it answers. Where did these ultralight particles come from? How do they fit into the bigger picture of physics? And what does this mean for our understanding of space, time, and reality itself? If dark matter isn't made of traditional particles but instead behaves like a quantum wave, then the very foundation of our understanding of the universe might need to be rewritten. It could mean that space isn't just a vast emptiness filled with galaxies and stars, but something much more fluid and dynamic. It could mean that the structure of the cosmos itself is shaped by strange, invisible ripples that stretch across billions of light years. And that brings us to one of the biggest mysteries of all. If dark matter is actually a wave-like field rather than a collection of particles, then what else might be lurking out there in the universe? Could there be other forms of invisible matter that we haven't even considered yet? Could the very laws of physics be hiding deeper layers of reality that we're only just beginning to uncover? If fuzzy dark matter is real, it could mean that the way we think about space itself is completely wrong. Instead of being a vast emptiness where objects simply move according to gravity, space could be more like an ocean, with waves of invisible matter rippling through it. And if that's the case, then what we think of as empty space might not be empty at all. It might be filled with shifting, quantum structures that shape everything from the movement of galaxies to the very nature of time itself. But let's go even deeper. One of the strangest implications of fuzzy dark matter is that it could explain some of the biggest inconsistencies in our understanding of the cosmos. For example, there's a huge problem with how galaxies form in traditional dark matter models. According to simulations based on the idea of heavy, slow-moving dark matter particles, galaxies should be packed with small, dense clumps of dark matter. These clumps should act like gravitational anchors, pulling in gas and forming new stars. But when we look at real galaxies, we don't see nearly as many of these clumps as the models predict. Instead, galaxies appear smoother and more spread out. Fuzzy dark matter could explain this. Since it behaves like a wave rather than a collection of individual particles, it wouldn't form those dense clumps. Instead, it would create smooth, wave-like distributions of mass, which matches what we actually see in the universe. Another major mystery that fuzzy dark matter could help solve is the core-crust problem. In simple terms, when astronomers look at the centers of galaxies, they expect to find a sharp peak in dark matter density, a cusp, because gravity should pull the dark matter toward the center. But in reality, we often see a smoother, flatter distribution, a core. This has been a big problem for traditional dark matter models, but fuzzy dark matter naturally explains it. Because it behaves like a wave, it can't be packed too tightly in one place. The quantum nature of these ultralight particles prevents them from collapsing into a sharp peak, leading to the smoother cores that we observe. And then there's the issue of dwarf galaxies. These are small galaxies that orbit larger ones, and they should give us valuable clues about how dark matter behaves. But when astronomers study them, they find some puzzling results. Many dwarf galaxies don't seem to behave the way traditional dark matter models predict. Some of them appear to be missing dark matter entirely, while others seem to be rotating in strange, unexpected ways. Fuzzy dark matter could help explain this, too. If dark matter is actually a quantum wave, then its distribution around galaxies might not be as predictable as we once thought. Some regions of space could have stronger or weaker dark matter fields depending on how the waves interfere with each other. This could lead to some galaxies having more dark matter and others having less, which would explain the strange patterns we see in dwarf galaxies. But it's not just small galaxies that hold clues. Some of the biggest questions about the universe itself might be connected to fuzzy dark matter. Take the cosmic web, for example. This is the vast, large-scale structure of the universe, a network of filaments made up of galaxies, stretching across billions of light-years. Scientists believe that dark matter plays a crucial role in shaping this structure, acting as a kind of cosmic scaffolding that holds everything together. If dark matter is made of heavy particles, then we'd expect to see a more chaotic, clumpy distribution of matter. But if it's made of ultralight, wave-like particles, then it would create a smoother, more coherent structure. And when astronomers look at the actual distribution of galaxies in the universe, they see something that looks much more like what fuzzy dark matter would predict. Now, here's where things start to get even weirder. If dark matter is actually a wave, then could it be interacting with itself in strange ways? Some scientists think so. In fact, there's a possibility that fuzzy dark matter could be forming interference patterns, similar to the ripples you see when you drop two stones into a pond. These interference patterns could be shaping the universe on a massive scale, creating subtle variations in the distribution of galaxies and even affecting how light travels through space. And speaking of light, there's another strange consequence of fuzzy dark matter that could help explain one of the biggest mysteries in physics: the nature of gravity itself. Right now, our best theory of gravity is Einstein's general relativity, which describes how massive objects bend space-time and create the force we experience as gravity. But there's a problem. General relativity works really well on large scales, like planets, stars, and galaxies, but it doesn't quite fit with quantum mechanics, which describes the tiny, subatomic world. Scientists have been trying for decades to figure out how to unify these two theories, but so far they haven't been able to. But what if fuzzy dark matter is the missing piece? Some physicists think that if dark matter is actually made of quantum waves, then it could be subtly influencing the way gravity works. Instead of gravity being a simple warping of space-time, it could be interacting with these quantum waves in ways we don't yet understand. This might explain some of the strange discrepancies we see in galaxy rotation curves and the motion of cosmic structures. It could even hint at a deeper, more fundamental theory of the universe, one that goes beyond Einstein's equations and into a whole new realm of physics. And here's another mind-blowing idea. What if fuzzy dark matter isn't just shaping space, but also time? If these quantum waves are everywhere, then could they be influencing the flow of time itself? We already know that gravity can affect time. Clocks run slower near massive objects like black holes. But if fuzzy dark matter is creating subtle, wave-like distortions in space, then it's possible that it could be affecting time in ways we haven't even considered yet. Could there be regions of space where time flows slightly differently because of the way dark matter waves interact? Could this be the key to understanding some of the strange time anomalies we've observed in space? And let's not forget about the Big Bang. If fuzzy dark matter is real, then it must have been present from the very beginning of the universe. That means it could have played a role in shaping the very first moments of cosmic history. Some scientists think that these ultralight particles could have influenced the inflationary period, the brief moment right after the Big Bang when the universe expanded at an incredible rate. If dark matter was already behaving like a giant quantum wave back then it could have left subtle imprints in the cosmic microwave background, the faint radiation left over from the birth of the universe. And if we could detect those imprints, it might give us the first real evidence that fuzzy dark matter is more than just a theory. But here's the big question: how do we prove it? Right now, the best way to test the idea of fuzzy dark matter is through astrophysical observations. Scientists are looking at the rotation curves of galaxies, the structure of the cosmic web, and even the motion of stars in the Milky Way to look for signatures of wave-like dark matter. Some are also exploring the possibility of using advanced telescopes to look for tiny distortions in light caused by dark matter waves. And then there are the gravitational wave experiments. If fuzzy dark matter is real, then it might create interference patterns in gravitational waves, subtle ripples in spacetime that we could detect with experiments like LIGO and Virgo. If we find those patterns, it could be a game changer for physics. But even if we do find evidence for fuzzy dark matter, that's just the beginning. If this theory is correct, then it could completely change how we think about the universe. It could mean that space isn't just an empty void, but a dynamic, shifting medium filled with invisible waves. It could mean that the structure of the cosmos is shaped by quantum mechanics on a massive scale. And it could mean that the true nature of reality is even stranger than we ever imagined. If fuzzy dark matter is real, it could mean that everything we thought we understood about the nature of space and time is just the surface of something far more complex. Imagine a universe where the very fabric of reality isn't static but constantly fluctuating due to the presence of these immense, invisible waves of dark matter. What if the way galaxies move, the way stars form, and even the way light bends through space is being influenced by an underlying quantum phenomenon we've only just begun to suspect? One of the strangest possibilities is that fuzzy dark matter might not just be affecting the motion of galaxies, but could also be interacting with black holes in ways we can't yet predict. Black holes are already some of the most mysterious objects in the universe. They warp space and time so intensely that nothing, not even light, can escape their grasp. But what happens if a black hole exists within a sea of fuzzy dark matter? Some physicists have proposed that dark matter waves could form giant halos around black holes, creating unique interference patterns that might be detectable with the right instruments. There's even speculation that fuzzy dark matter could slow down the spin of black holes. Normally, when black holes consume matter, they gain angular momentum and spin faster. But if dark matter waves are surrounding the black hole, their quantum interactions could act like a kind of invisible friction, draining some of that rotational energy. If this is true, then we should be able to observe differences in the spin rates of black holes in regions with varying densities of dark matter. Scientists are already looking at data from gravitational wave detectors to see if this effect could be real. And then there's the question of what happens inside black holes themselves. Right now, our best theories suggest that anything that falls into a black hole is lost forever, crushed into a singularity where space and time cease to exist. But some researchers have speculated that if fuzzy dark matter exists, then the inside of a black hole might not be a singularity at all. Instead, it could be a region where dark matter waves interact in ways we can't yet understand, potentially leading to exotic new physics. Could there be a way for information to escape a black hole through these quantum interactions? Could dark matter waves hold the key to understanding what really happens beyond the event horizon? The implications of fuzzy dark matter don't stop with black holes. There's another huge mystery that has puzzled astronomers for decades: dark energy. Dark energy is the force that's causing the universe to expand at an accelerating rate, and right now, we have almost no idea what it actually is. But some theories suggest that dark energy and dark matter might be two sides of the same coin. If fuzzy dark matter is real, then it's possible that its quantum wave properties could be influencing the expansion of the universe itself. Think about it like this: if the universe is filled with ultralight dark matter waves, then those waves could be interacting with the fabric of spacetime in ways we don't yet understand. Instead of dark energy being a completely separate force, it might actually emerge from the way fuzzy dark matter behaves on cosmic scales. If this is true, then dark matter isn't just shaping the structure of the universe. It could be playing a role in its ultimate fate. And speaking of the fate of the universe, what does fuzzy dark matter mean for the long-term evolution of everything? Right now, There are multiple theories about how the universe might end. Some suggest that dark energy will continue pushing galaxies apart until the cosmos becomes a cold, empty void. Others propose that gravity could eventually pull everything back together in a big crunch. But if fuzzy dark matter is real, then there's another possibility, the big wave. If dark matter is really a quantum wave phenomenon, then it's possible that its properties could change over time. What if, billions or even trillions of years from now, the nature of these waves shifts in a way that alters the balance of forces in the universe? Could there be a point where dark matter waves collapse or reorganize, triggering a massive transformation in the structure of space itself? Could this be the key to understanding whether the universe will end, or simply transition into something new? But before we get ahead of ourselves, let's bring things back to the present. How do we actually test the idea of fuzzy dark matter? One of the best ways to look for evidence is by studying the way light bends around galaxies. When light from distant stars passes through a galaxy, the gravitational field of that galaxy bends the light, creating a phenomenon called gravitational lensing. If dark matter is made of heavy particles, then we'd expect to see sharp, distinct distortions in the light. But if dark matter is made of waves, then those distortions should be smoother and more spread out. Scientists are already analyzing gravitational lensing data from telescopes like the Hubble Space Telescope and the upcoming James Webb Space Telescope to see if they can find patterns that match fuzzy dark matter predictions. Another potential test comes from pulsars, rapidly spinning neutron stars that emit incredibly precise beams of radiation. Pulsars act like cosmic clocks, and any small change in the way their light reaches us can reveal subtle disturbances in space. If dark matter is a wave, then its fluctuations might create tiny shifts in the timing of pulsar signals. By carefully monitoring pulsars across the galaxy, astronomers might be able to detect the telltale signs of fuzzy dark matter waves rippling through space. And let's not forget about laboratory experiments. While most dark matter research focuses on space, some scientists are looking for ways to detect fuzzy dark matter right here on Earth. Since these particles are ultralight, they wouldn't interact with normal matter in the way traditional dark matter particles might. But they could still create tiny effects in high-precision experiments. For example, some researchers are using ultra-sensitive atomic clocks to look for minute variations in time that could be caused by passing dark matter waves. Others are designing experiments using supercooled atoms to see if they can detect quantum interference patterns that might be linked to dark matter. If we do find evidence for fuzzy dark matter, it would be one of the most groundbreaking discoveries in modern physics. It wouldn't just change our understanding of dark matter, it would force us to rethink the fundamental nature of the universe. It would mean that the cosmos isn't just a collection of objects moving through space, but a vast, interconnected web of quantum waves shaping reality at every level. And if fuzzy dark matter is real, then what else is out there that we haven't even considered yet? Could there be other hidden quantum fields influencing the universe in ways we haven't yet imagined? Could the structure of space itself be more dynamic and fluid than we ever realized? And most importantly, if dark matter is made of waves, then could there be a way for us to manipulate those waves? What if, in the distant future, humanity figures out how to harness the properties of fuzzy dark matter? Could we one day learn to manipulate these invisible waves to control gravity itself? Could we use them to bend space and time, opening the door to technologies that seem impossible today? If dark matter is really the key to understanding the fundamental nature of the universe, then unlocking its secrets could be the first step towards something even greater, a deeper, more complete understanding of reality itself. If we ever confirm the existence of fuzzy dark matter, it would completely transform not just astrophysics, but also the way we think about the universe on every scale. It would mean that the cosmos isn't simply a vast emptiness filled with scattered galaxies, but instead, a deeply interconnected structure where invisible quantum waves ripple through space, influencing everything from the formation of stars to the very expansion of the universe itself. And that raises even bigger questions. If dark matter is truly made of waves, then what else is out there that we haven't even begun to detect? One of the most intriguing possibilities is that fuzzy dark matter might not be the only strange quantum field shaping the universe. What if there are other hidden forces or particles that exist in a similar state, creating effects we haven't yet recognized. Some physicists have even suggested that dark matter might be linked to exotic particles that exist in entirely different dimensions that, so far, remain invisible to us. The idea might sound extreme, but modern theories like string theory already suggest that our universe might be far more complex than what we can directly observe. If fuzzy dark matter is real, it could be a clue that our reality is built on a far deeper and more intricate foundation than we ever suspected. But let's take a step back and think about something even more mind-bending. If fuzzy dark matter is made of waves, then does that mean it could interact with itself in strange and unexpected ways? In quantum mechanics, waves don't just pass through each other like simple ripples in a pond. Instead, they can interfere, amplify, and cancel each other out, creating incredibly complex patterns of motion. If dark matter follows similar principles, then what does that mean for the large-scale structure of the universe? Could there be hidden interference patterns across cosmic distances, shaping galaxies and clusters in ways we've never even thought to look for? And what about the possibility of localized, hot spots of dark matter waves? If dark matter is made of ultralight particles, then their wavelengths would be enormous, potentially larger than entire galaxies. But within those vast waves, there could be regions where the density fluctuates in strange and unexpected ways. Could there be places in the universe where dark matter waves focus and amplify, creating regions with unusual gravitational effects? Could these be the missing pieces in our understanding of galactic rotation, the movement of galaxy clusters, or even unexplained anomalies in cosmic background radiation? And here's another question. If fuzzy dark matter can form wave-like structures, could it also create something even stranger? In traditional quantum physics, particles can sometimes form stable, wave-like solitons, self-reinforcing waves that travel without dispersing. If dark matter behaves in a similar way, then could there be vast, stable dark matter structures floating through space, acting as invisible gravitational lenses that subtly distort the light from distant galaxies? Could this explain some of the strange, unexplained gravitational effects we've observed in deep space, effects that don't seem to match what we expect from ordinary dark matter models? And here's where things get even weirder. If dark matter waves can form solitons, could they also interact with ordinary matter in ways we haven't yet detected? Could these invisible wave-like structures create subtle changes in the behavior of stars, planets, or even fundamental particles? Could there be a way, however faint, for dark matter to influence the chemistry of the universe, shaping the evolution of galaxies and planetary systems in ways we've never imagined? There's also the possibility that fuzzy dark matter could explain one of the biggest mysteries in all of cosmology: why the universe appears to be so perfectly structured for life. Right now, scientists struggle to understand why the fundamental forces of the universe seem to be so finely balanced. If the strength of gravity were just slightly different, galaxies wouldn't have formed. If the properties of particles were slightly different, atoms wouldn't exist. This delicate balance is often called the fine-tuning problem, and no one really knows why the universe is set up this way. But if dark matter is made of waves, then could there be an underlying quantum structure that naturally leads to these precise balances? Could the interference patterns of fuzzy dark matter be part of the reason why the universe seems so strangely ordered? And if that's the case, then what does that say about the nature of reality itself? Is the universe truly random, or is it following some deeper, hidden rules that we haven't yet uncovered? Could fuzzy dark matter be the first hint of a much more profound principle, one that explains why the cosmos is the way it is? These questions might sound like pure speculation, but they aren't just theoretical. Right now, scientists are actively searching for signs that could confirm, or disprove, the idea of fuzzy dark matter. Observatories are scanning distant galaxies, looking for the subtle signatures of wave-like distortions and gravitational lensing. Experiments on Earth are searching for tiny, unexplained shifts in atomic clocks that could hint at the presence of dark matter waves. And as new technology emerges, we're likely to find even more ways to test these ideas. But the biggest breakthroughs might come from places we haven't even thought to look yet. Could the echoes of fuzzy dark matter be hiding in the cosmic microwave background, the faint afterglow of the Big Bang? Could there be hidden patterns in the motion of stars, revealing the presence of dark matter waves in ways we've never noticed before? Could future gravitational wave detectors, far more sensitive than anything we have today, uncover the subtle tremors of dark matter rippling across the cosmos? And if we do find evidence, then what happens next? Would confirming the existence of fuzzy dark matter lead to new physics, new equations that rewrite our understanding of space and time? Would it open the door to new technologies, allowing us to manipulate gravity or even tap into the hidden energies of the quantum universe? Could it be the first step towards something even more incredible, an entirely new way of understanding reality? Right now, we don't have the answers. But if fuzzy dark matter is real, then we may be on the edge of one of the biggest scientific revolutions in history. It could change everything, from the way we see the stars to the way we see ourselves. And the only question left is this: are we ready to find out? If we are truly on the verge of discovering fuzzy dark matter, the implications could be more profound than we can even comprehend right now. It wouldn't just be a small tweak to our understanding of the universe. It could fundamentally change the way we think about physics, reality, and even our own place in the cosmos. Because if dark matter isn't made of particles the way we once thought, but rather of vast quantum waves stretching across galaxies, then what else about the universe might be completely different from what we assume? Could the very fabric of space-time itself be shaped by quantum effects that we haven't yet detected? Could gravity, the force that holds everything together, be influenced by hidden wave-like structures that ripple through the universe, altering the movement of galaxies in ways we never imagined? Some physicists have even proposed that dark matter might not just be a passive background force. It could be dynamically shaping the universe in ways we haven't considered. For example, if fuzzy dark matter forms wave-like structures, then could those structures interact with ordinary matter in subtle but meaningful ways? Could dark matter waves be influencing the formation of galaxies, helping them take on their familiar spiral shapes? Could they be affecting the way stars form, or even playing a role in the creation of planetary systems like our own? And if dark matter is interacting with normal matter, even in ways too subtle for us to notice right now, then what does that mean for the laws of physics? Could there be tiny, unnoticed effects caused by these waves, affecting the behavior of fundamental particles? Could dark matter be the missing piece in our attempts to unify quantum mechanics and general relativity, two theories that currently don't fit together, but which might finally make sense if we introduce the idea of wave-like dark matter? And then there's the biggest question of all: what does this mean for our understanding of reality itself? If the universe is filled with vast, invisible waves that stretch across cosmic distances, then could that be part of a larger pattern we haven't yet recognized? Could it be connected to the way quantum mechanics works on the smallest scales, where particles can exist in superpositions, behaving as both waves and particles at the same time? And if that's true, then does that mean the entire universe is, in some way, part of a deeper quantum reality? Could space and time themselves emerge from these hidden wave-like structures, meaning that everything we experience, from the motion of galaxies to the passage of time, might be the result of underlying quantum processes we haven't yet fully understood? It's a staggering idea, but it's one that some of the greatest physicists in the world are beginning to take seriously. Because if fuzzy dark matter is real, then it might be the first clue to something much, much bigger, a new way of understanding the universe, one that goes beyond classical physics and takes us into a realm where space, time, and even reality itself might be shaped by hidden, unseen forces. And that leads us to the final, most mind-bending question of all. If dark matter is made of waves, then could it be possible to manipulate those waves? Could we one day develop the technology to interact with dark matter, to shape or control these invisible structures in ways we can't even begin to imagine yet? Could this be the key to unlocking entirely new forms of technology, new ways of understanding physics, or even new ways of traveling through the cosmos? Right now, we don't have the answers. But one thing is certain: fuzzy dark matter is one of the strangest, most intriguing ideas in modern physics. If it's real, then it could change everything we know about the universe. And the only way to find out the truth is to keep searching, keep asking questions, and keep pushing the limits of what we think is possible. Because in the end, that's what science is all about. It's about looking at the unknown and daring to ask, what if? If fuzzy dark matter is real, then it raises another deep and unsettling question. Why does it exist at all? What force or mechanism created it? Is it simply a byproduct of the early universe? Or is it pointing to something even more fundamental about the nature of reality? Right now, our best understanding of the cosmos tells us that dark matter must have formed very early in the history of the universe, perhaps within the first fractions of a second after the Big Bang. But if fuzzy dark matter is made of ultralight particles, then it suggests that something was responsible for creating an incredibly delicate balance in the early universe. Why would the cosmos naturally produce matter that behaves like waves on such an enormous scale? One possibility is that fuzzy dark matter is linked to a deeper, hidden structure within the universe itself, something beyond even what our current theories of physics can describe. Some scientists have proposed that these ultralight particles might be connected to a concept called axions, a type of hypothetical particle that could explain several of the biggest mysteries in physics, including why fundamental forces like electromagnetism behave the way they do. If fuzzy dark matter is made of axions or a similar type of particle, then it could mean that dark matter isn't just an isolated mystery. It might be part of a much larger framework that governs how the entire universe functions. And that leads to an even bigger question. If dark matter is made of waves, then what else in the universe might be shaped by the same underlying principles? Could it be that normal matter, the atoms and molecules that make up everything we see, is also influenced by similar quantum wave structures, but in ways that we haven't yet detected? Could the very fabric of reality itself be shaped by the same forces that give rise to fuzzy dark matter? One of the most intriguing possibilities is that dark matter waves could be creating hidden patterns in the structure of space-time. Right now, our best model of the universe, known as the lambda-cold dark matter model, assumes that dark matter is essentially a static, invisible framework that galaxies are built upon. But if fuzzy dark matter is real, then that assumption might be completely wrong. Instead of being a rigid structure, dark matter might be more like an ocean, with vast, slow-moving waves rippling through space, subtly altering the way galaxies form and evolve. And if that's true, then it could mean that our entire understanding of cosmic evolution needs to be rewritten. Right now, scientists assume that galaxies form through a process of gravitational attraction, where normal matter collapses into stars and planets under the influence of dark matter's pull. But what if dark matter waves play a more active role in this process? What if the shapes and structures of galaxies are being sculpted not just by gravity, but also by the interference patterns of invisible waves stretching across cosmic distances? If this idea is correct, then it could solve one of the biggest puzzles in astrophysics: the strange distribution of satellite galaxies around larger galaxies like the Milky Way. Observations have shown that many of these smaller galaxies appear to be arranged in unexpected patterns, almost as if they were following some kind of invisible structure. Traditional dark matter models struggle to explain this, but fuzzy dark matter could provide an answer. If dark matter is made of waves, then those waves could be creating interference patterns that guide the formation of galaxies in ways we never anticipated. But if dark matter waves are influencing the structure of galaxies, then what about even larger cosmic structures? Could they be shaping entire clusters of galaxies, or even the massive filaments that make up the cosmic web? Right now, scientists believe that the large-scale structure of the universe is primarily governed by dark matter, forming vast networks of filaments that connect clusters of galaxies together. But if those filaments are actually shaped by wave-like interference patterns, then it could mean that the entire structure of the cosmos is built upon a hidden quantum framework, one that we are only just beginning to understand. And if dark matter waves are creating interference patterns on cosmic scales, then could they also be affecting something even more fundamental: the expansion of the universe itself? Right now, one of the biggest unsolved mysteries in physics is why the universe is expanding at an accelerating rate, a phenomenon that scientists attribute to a mysterious force called dark energy. But what if dark energy and fuzzy dark matter are actually connected? Could it be that the wave-like nature of dark matter is influencing the way space-time expands, creating effects that we currently interpret as dark energy? Some physicists have suggested that ultralight dark matter could have properties that allow it to interact with the very fabric of space-time, potentially influencing the rate at which the universe expands. If this idea is correct, then it could mean that dark matter isn't just shaping the structure of galaxies. It could be playing a direct role in the evolution of the entire universe. And that raises another question. If dark matter is made of waves, then could those waves be changing over time? Could the properties of dark matter have been different in the past? And could they change again in the future? If so, then it could mean that the universe itself is evolving in ways we haven't yet realized. But here's where things get even more bizarre. If fuzzy dark matter is real, and if it truly behaves like waves, then does that mean it could one day be manipulated? Could there be advanced civilizations, somewhere out there in the vastness of space, that have already learned how to harness dark matter waves, using them to develop technologies that are beyond anything we can currently imagine? Right now, we have no way of knowing. But if fuzzy dark matter exists, then it means the universe is far stranger and more complex than we ever imagined. And as we continue to push the boundaries of what we know, we may find that the secrets of dark matter are just the beginning of an even greater mystery, one that could change everything we thought we knew about the cosmos. If fuzzy dark matter is real and it truly behaves like vast, invisible waves rippling across the universe, then we have to consider something even more mind-blowing. Are these waves carrying information? In quantum mechanics, wave-like behavior is deeply connected to the concept of information. When we look at fundamental particles like electrons or photons, their wave-like nature means that they don't just exist in one place at one time. Instead, they exist as a probability wave, a spread-out state that only collapses into a definite position when it is measured. Now, imagine applying this concept to the entire universe. If fuzzy dark matter is made of waves, then those waves might not just be shaping galaxies. They could be encoding information in a way we don't yet understand. And if that's the case, then dark matter could be functioning as a kind of cosmic memory, a hidden record of the past stretching across billions of years. What if the structure of dark matter waves holds imprints of the earliest moments of the universe? If dark matter is a quantum wave phenomenon, then in theory, it could contain traces of the quantum fluctuations that existed in the first moments after the Big Bang. This means that instead of being just a passive background, dark matter might actually hold a deep, hidden history, one that we might one day be able to decipher. But if dark matter can store information, then does that mean it can also be influenced? In quantum mechanics, wave-like systems can interact and interfere with each other. Could it be possible that, under the right conditions, dark matter waves could be manipulated? Could we, at some point in the distant future, develop a way to tap into these invisible waves and extract information from them? And here's where things get even more bizarre. If dark matter waves can encode information, then is it possible that they could also be used as a means of communication? We currently rely on electromagnetic waves, radio signals, light waves, and so on, to send information across space. But what if dark matter provides an alternative? Imagine a civilization advanced enough to manipulate dark matter waves directly. Instead of sending radio signals, they could send quantum wave patterns, embedding messages within the very fabric of the universe itself. These signals wouldn't be affected by normal matter, wouldn't be blocked by planets or stars, and could potentially travel across vast cosmic distances without losing their strength. If such a technology existed, it would be completely undetectable to us right now. Our instruments are designed to pick up electromagnetic signals, not oscillations in a hypothetical ultralight dark matter field. But if an advanced civilization had already discovered how to manipulate fuzzy dark matter, then they might be communicating in a way that we simply haven't learned to recognize yet. And that leads to an even stranger thought. If dark matter waves can carry information, then could they also carry consciousness? Right now, we assume that consciousness emerges from the complex interactions of neurons in the brain. But some theories suggest that consciousness might be connected to quantum processes, meaning that it could, in some way, be linked to wave-like structures at a fundamental level. If that's true, then could it be possible that dark matter waves play a role in consciousness itself? Could our thoughts, our awareness, even our sense of self, be subtly influenced by quantum waves that permeate the universe? It's a wild idea, but some physicists have speculated that dark matter might be connected to hidden dimensions or unknown physical principles that go beyond our current understanding. If fuzzy dark matter is real, then it forces us to rethink everything we assume about the cosmos. It suggests that the universe isn't just a collection of galaxies moving through empty space. It's a vast, interconnected system shaped by hidden wave-like structures that could be influencing everything from the motion of planets to the formation of consciousness itself. And the biggest mystery of all? We are only just beginning to explore these possibilities. Right now, dark matter remains one of the greatest unsolved puzzles in physics. But every new discovery brings us one step closer to understanding its true nature. What we find next could change everything. If fuzzy dark matter truly exists and behaves as a vast ocean of quantum waves, then we must ask a question that might shake the very foundation of physics. Could these waves interact with reality in ways we have never imagined? If dark matter is not just a passive substance but an active, vibrating field stretching across the cosmos, then what if its undulations influence the way time, gravity, and even the fundamental forces of nature behave? Right now, we think of dark matter as an invisible scaffold that shapes galaxies, but what if it is something far more dynamic? What if the structure of space itself is being constantly molded by the ebb and flow of these hidden waves, creating a universe that is not just expanding, but fluctuating on a level so subtle that we have not yet learned to detect it? If so, then fuzzy dark matter may not just be an answer to an existing mystery. It may be the key to a deeper understanding of reality itself, one that overturns everything we assume about the nature of existence. One of the strangest implications of fuzzy dark matter is that it might redefine how we think about space and time. In physics, space is often treated as a kind of three-dimensional stage on which matter and energy interact, while time is thought of as a separate dimension that moves forward at a constant rate. But if dark matter is made of waves, then it might not simply exist within space-time, it might be actively shaping it. These waves could be creating subtle variations in the structure of the universe itself, meaning that space might not be as uniform as we assume. In some regions, dark matter waves might be densely packed, creating stronger gravitational effects, while in other areas, the waves might be spread thin, leading to weaker gravitational interactions. If this is true, then the very concept of empty space might be an illusion. What we perceive as nothingness could be a sea of hidden motion, a constantly shifting landscape of quantum waves that ripple invisibly across the cosmos. But what if these waves do more than just shape the universe? What if they influence the way time itself flows? If dark matter waves create interference patterns, then those patterns might cause time to stretch or contract in ways that we do not yet understand. Imagine that instead of time moving forward at a fixed rate, it is subtly affected by the undulations of dark matter, speeding up in some regions of space and slowing down in others. Could it be that the reason some galaxies appear to rotate faster than expected is not just because of an unseen gravitational force, but because dark matter waves are altering the passage of time itself? If this is true, then our entire understanding of cosmic history might need to be rewritten. Events that we assume happened at one pace might have actually unfolded differently, shaped by invisible distortions in the fabric of time created by the movement of dark matter waves. If dark matter waves are actively shaping time and space, then it is worth considering whether they might also be responsible for other unexplained cosmic phenomena. One of the greatest mysteries in modern physics is the nature of dark energy, the force that appears to be driving the accelerated expansion of the universe. Right now, dark energy is treated as a completely separate mystery from dark matter, an unknown force that counteracts gravity and pushes galaxies apart at an ever-increasing rate. But what if dark energy is not actually separate from dark matter at all? What if the accelerating expansion of the universe is not caused by some mysterious force, but rather by the behavior of dark matter waves themselves? If fuzzy dark matter is real, then its wave-like nature means that it is constantly in motion, spreading out and oscillating in ways that could influence the large-scale structure of the cosmos. It is possible that what we currently interpret as dark energy is actually just the cumulative effect of dark matter waves shifting over time, stretching the fabric of space in a way that creates the illusion of an accelerating universe. And if that is the case, then it could mean that the fate of the universe is far more unpredictable than we currently assume. Right now, many scientists believe that the universe will continue expanding forever, with galaxies drifting apart until everything is spread too thin for new stars to form. But if dark matter waves are playing an active role in shaping cosmic expansion, then this process might not be as simple as we think. It is possible that dark matter waves could shift in such a way that the expansion of the universe slows down, or even reverses. If the underlying structure of dark matter is constantly evolving, then we cannot assume that the universe will behave in a straightforward manner. The very fabric of space-time might be subject to hidden cycles of expansion and contraction, governed by the movements of dark matter waves in ways we do not yet comprehend. But the implications of fuzzy dark matter do not stop at the cosmic scale. If dark matter waves are real, then they may also have effects on the quantum world, effects that could challenge some of our most fundamental assumptions about reality. In quantum mechanics, particles behave as both particles and waves, existing in superpositions of multiple states until they are observed. But if dark matter itself is wave-like, then it might mean that the quantum world is not just governed by the interactions of particles, but by a deeper, hidden wave structure that permeates everything. Could it be that dark matter waves are the missing link between the macroscopic and quantum realms, an unseen field that influences how reality takes shape at the smallest scales? If so, then it could mean that our current understanding of quantum mechanics is incomplete, missing a crucial layer of complexity that connects the behavior of individual particles to the vast, wave-like patterns of dark matter on a cosmic scale. And if dark matter waves influence quantum mechanics, then what does that mean for the nature of consciousness? Some theories suggest that consciousness itself might emerge from quantum processes occurring within the brain, meaning that if dark matter waves affect quantum systems, they could, in theory, have an impact on thought itself. Could it be that the very structure of human awareness is, in some subtle way, shaped by the same hidden waves that govern the structure of galaxies? If dark matter waves permeate all of space, then they must also pass through us, constantly interacting with the atoms that make up our bodies. While this idea is purely speculative, it raises an incredible possibility. Could the presence of dark matter waves have played a role in the emergence of life itself? If the conditions of the early universe were shaped by dark matter oscillations, then it is possible that the structure of space-time, the behavior of matter, and even the formation of planets were all subtly influenced by these invisible waves. If so, then life as we know it might not simply be the result of random chance and chemical interactions. It might be deeply connected to a hidden, wave-like structure that underlies all of reality. This leads to an even more profound question. If dark matter waves influence the cosmos, and if they can potentially interact with quantum systems, then is it possible that they can be harnessed in some way? Right now, humanity has barely begun to understand dark matter, let alone manipulate it. But if dark matter waves are real, then they might represent a resource of unimaginable potential. Could a sufficiently advanced civilization develop technology capable of detecting and controlling these waves? Could dark matter be used as a means of communication, a form of energy storage, or even a tool for manipulating space-time itself? If dark matter waves are fundamental to the structure of the universe, then understanding them could open the door to entirely new branches of science, ones that go beyond anything we currently conceive. At this moment, we are only beginning to scratch the surface of what fuzzy dark matter might mean for our understanding of the cosmos. Every discovery we make brings us closer to answering the fundamental questions about the universe, but each answer only reveals new mysteries waiting to be solved. The existence of dark matter waves would not just explain the movement of galaxies, it would redefine our place in the universe, forcing us to confront the possibility that reality itself is far stranger and more complex than we ever imagined. And as we continue to search for answers, one thing remains certain. The deeper we look into the mysteries of space, the more we realize that the greatest discoveries may still lie ahead. If fuzzy dark matter truly exists as a sea of quantum waves rippling through the cosmos, then we must consider the implications for not just astronomy and physics, but for the very nature of existence itself. Could these waves be more than just passive participants in shaping galaxies? Could they be actively influencing the structure of reality in ways we have never even thought to measure? Right now, our understanding of dark matter is limited to its gravitational effects, But what if its wave-like properties extend into realms of physics we have yet to explore? If these waves interact with fundamental forces, they could be subtly influencing the way particles behave, the way time flows, or even the way the universe itself evolves. One of the most intriguing possibilities is that fuzzy dark matter could serve as a hidden medium for transmitting information across vast cosmic distances. If dark matter waves are oscillating throughout the universe, they may be capable of carrying signals or disturbances that could be detected if we knew how to look for them. This raises an astonishing question. Could there be messages encoded within the structure of dark matter itself? If an advanced civilization had mastered the ability to manipulate these waves, they might be able to send information across the cosmos in ways that would be completely undetectable by conventional means. Instead of relying on electromagnetic signals, which weaken over distance, they could encode data directly into the fabric of dark matter, allowing it to propagate across galaxies without degradation. But what if fuzzy dark matter is not just a medium for information, but a fundamental aspect of consciousness itself? Some physicists have speculated that quantum processes in the brain might play a role in human consciousness, meaning that if dark matter waves influence quantum mechanics, they could, in theory, interact with thought processes in ways we do not yet understand. This leads to a mind-bending possibility. What if the very structure of thought is connected to these cosmic waves? If dark matter permeates everything, then it must also pass through our bodies, interacting with the particles that make up our neurons and synapses. Could it be that our perception of reality is subtly influenced by the waves of dark matter flowing through us? If this is true, then it raises another profound question. What if dark matter waves hold the key to understanding life itself? Right now, scientists do not fully understand why the universe seems to be so well tuned for life. The fundamental constants of physics, the strength of gravity, the charge of the electron, the properties of atomic nuclei, seem to be precisely balanced in a way that allows complex structures to form. If these constants were even slightly different, stars would not burn properly, planets would not form, and life as we know it would be impossible. But what if this fine-tuning is not just a coincidence? What if it is the result of interactions between ordinary matter and dark matter waves? If dark matter has been influencing the evolution of the cosmos from the very beginning, then it might have played a crucial role in creating the conditions necessary for life to exist. And if dark matter waves played a role in the emergence of life, then they might also play a role in its future evolution. Some theories suggest that life in the universe may not be limited to carbon-based organisms like those found on Earth. If dark matter waves can interact with quantum mechanics, then it is possible that entirely different forms of life, ones based on exotic physics we have yet to discover, could exist within the hidden framework of the cosmos. Could there be entities composed entirely of dark matter, living in a reality parallel to our own, completely undetectable to us? If so, then we might not be alone in the universe in the way we assume. Intelligent life could exist all around us, interacting with the same physical space but through forces we do not yet comprehend. But if dark matter waves hold such profound implications for the nature of the universe, then why have we not detected them directly? The answer may lie in the way we conduct experiments. Most of our current methods for studying dark matter rely on measuring gravitational effects, but if dark matter is truly wave-like, then it might require an entirely different approach. Instead of looking for discrete particles, we might need to search for interference patterns, oscillations, or subtle distortions in the behavior of matter and energy. Some scientists have proposed that ultra-cold atom experiments, where atoms are cooled to near absolute zero and observed for quantum effects, could reveal the presence of dark matter waves. If these experiments detect anomalies that cannot be explained by known physics, it could be a sign that dark matter is interacting with the quantum world in unexpected ways. Another possibility is that dark matter waves are simply too large or too slow to be detected by our current instruments. If these waves have wavelengths on the scale of galaxies, then their effects might only be noticeable over cosmic timescales. This means that instead of looking for immediate changes, we may need to study the long-term evolution of cosmic structures to detect their influence. If galaxies exhibit behaviors that cannot be explained by normal physics, such as unexplained shifts in their rotation or variations in their density, then it could be a sign that dark matter waves are at work. If we do manage to detect fuzzy dark matter directly, then it could open up entirely new possibilities for science and technology. Right now, our ability to manipulate matter and energy is limited to known particles and forces. But if dark matter waves can be harnessed, then we might gain access to an entirely new form of interaction with the universe. Imagine a future where we can manipulate the structure of space itself, creating gravitational distortions or even bending time in ways that were previously thought impossible. If dark matter waves can be controlled, then they might serve as the foundation for advanced propulsion systems, energy generation, or even methods of instantaneous communication across vast distances. But with this knowledge comes a potential danger. If fuzzy dark matter is truly fundamental to the structure of reality, then any attempt to manipulate it could have unforeseen consequences. Just as tampering with the fabric of space-time could lead to unpredictable distortions, altering the behavior of dark matter waves might create effects that ripple across the cosmos in ways we do not yet understand. Could it be that dark matter is not just a passive force, but an essential stabilizing factor in the universe? If so, then disturbing it might lead to catastrophic disruptions in the balance of nature, altering the way galaxies evolve or even affecting the passage of time itself. This raises one final, mind-bending question: what if we are not the first to consider these possibilities? If an advanced civilization somewhere in the cosmos had already discovered the secrets of fuzzy dark matter, then they might have learned how to harness its power long ago. Could it be that some of the strange cosmic phenomena we observe, such as unexplained fast radio bursts, mysterious fluctuations in cosmic background radiation, or even the anomalies in galaxy rotation, are the results of experiments conducted by an intelligence far beyond our own? If a civilization had gained control over dark matter waves, they might be capable of altering the structure of the universe itself, leaving behind faint traces of their activity in the form of unexplained cosmic signatures. And if that is the case, then we must consider another possibility. What if the reason we have not encountered intelligent extraterrestrial life is because they have transcended the limitations of ordinary matter? If a species had evolved to the point where they could integrate themselves into the structure of dark matter waves, then they might exist in a state that is completely undetectable to us. Instead of traveling through space in physical starships, they might move through the universe as pure waveforms, inhabiting a reality that is beyond anything we can currently comprehend. The deeper we dive into the mysteries of dark matter, the more we realize that we are only scratching the surface of a far greater puzzle. Every answer we find leads to new questions, each one more profound than the last. If fuzzy dark matter is real, then it could be the key to unlocking secrets about the universe that go far beyond what we ever imagined. The true nature of reality may be far stranger than we can currently grasp, and the greatest discoveries may still be waiting for us, hidden within the unseen waves that ripple through the fabric of existence itself. If fuzzy dark matter is truly the unseen force shaping our universe, then understanding it might be the most important scientific challenge of our time. It is not just about solving a cosmic mystery, it is about redefining our understanding of reality itself. Right now, we perceive the universe through the lens of ordinary matter, electromagnetic radiation, and gravity. But what if these are just surface-level phenomena? What if, beneath the reality we experience, there exists a deeper framework woven from the oscillations of dark matter waves? If this is true, then everything we think we know about space, time, and even existence could be incomplete. One of the most fascinating implications of fuzzy dark matter is that it challenges the way we think about space itself. Normally, we imagine space as a vast emptiness, a vacuum where galaxies, stars, and planets are scattered like islands in an ocean. But if dark matter waves permeate everything, then space is not truly empty. It is filled with an invisible, ever-shifting structure that we have yet to perceive. This could mean that space itself is more dynamic than we ever imagined. Instead of being a passive backdrop where events unfold, it could be an active medium, shaped and influenced by the rippling waves of dark matter. If dark matter is truly wave-like, then it could also mean that our understanding of gravity is incomplete. Right now, gravity is described by Einstein's general theory of relativity, which explains it as the curvature of spacetime caused by mass. But what if gravity is not just a geometric effect, but also a product of interactions between matter and dark matter waves. If this is the case, then our entire approach to understanding black holes, cosmic expansion, and even time itself might need to be reconsidered. This idea could also explain some of the biggest unsolved mysteries in physics. For example, one of the greatest puzzles in modern cosmology is the nature of dark energy, the mysterious force causing the universe to expand at an accelerating rate. Some scientists have suggested that dark energy might be connected to the quantum properties of space. But what if it is actually a result of fuzzy dark matter waves influencing cosmic evolution? If dark matter is oscillating throughout the universe, then it might be generating subtle fluctuations in spacetime that drive the expansion we observe. But the implications do not stop there. If dark matter waves are shaping the universe on a cosmic scale, then they might also be playing a role in the structure of galaxies, solar systems, and even planetary environments. This raises an incredible possibility. What if dark matter waves have been influencing the conditions necessary for life to exist? Right now, scientists are trying to understand why Earth seems to be so perfectly suited for life. Our planet orbits at just the right distance from the Sun, has the right mix of elements, and has a magnetic field that protects it from harmful radiation. But what if this is not just a coincidence? What if the subtle influence of dark matter waves played a role in shaping the conditions that allowed life to emerge? This leads to an even more astonishing question. What if dark matter waves are influencing life in ways we do not yet understand? Some scientists have proposed that quantum mechanics might be involved in biological processes, such as photosynthesis, enzyme reactions, and even consciousness. If this is true, then it is possible that dark matter waves are interacting with living systems on a fundamental level. This could mean that our understanding of biology is incomplete, and that life itself might be deeply connected to the hidden physics of the universe. And if life is influenced by dark matter, then it raises another profound possibility. What if there are forms of life that exist entirely within the realm of dark matter? Right now, our search for extraterrestrial life is focused on detecting biological signatures, such as oxygen, water, and organic molecules. But if dark matter has unique physical properties, then it could support life forms that are completely different from anything we have ever encountered. These beings might exist in a parallel state, unseen and undetectable by conventional means, yet coexisting with our reality in ways we cannot yet perceive. If this is true, then it might explain some of the most perplexing anomalies in astrophysics. Could some of the unexplained fluctuations in cosmic background radiation, the strange movements of certain celestial objects, or the missing mass in galaxy clusters be the result of interactions with unknown entities composed of dark matter? If dark matter waves can carry information or even consciousness, then we may need to rethink our entire approach to the search for extraterrestrial intelligence. Instead of looking for radio signals or chemical signatures, we might need to develop new methods to detect disturbances in the fabric of dark matter itself. But if fuzzy dark matter is truly the key to unlocking the deepest mysteries of the cosmos, then why has it remained so elusive? The answer may lie in the nature of the waves themselves. If dark matter behaves like an ultralight quantum field, then its interactions with normal matter might be so weak that they are almost impossible to detect with current technology. Instead of being a substance that can be directly measured, it may only reveal itself through its large-scale effects on galaxies, gravity, and space-time. This presents a major challenge for scientists. If dark matter waves cannot be directly observed, then how can we prove that they exist? One possible approach is to look for their indirect effects, subtle shifts in the motion of stars, unexplained variations in gravitational fields, or anomalies in the behavior of quantum systems. Some experiments are already underway to test these ideas. Researchers are using precision atomic clocks to look for minute disturbances in time that could be caused by passing dark matter waves. Others are studying the rotation curves of galaxies in unprecedented detail, searching for patterns that might reveal the presence of an underlying wave-like structure. If we do succeed in detecting fuzzy dark matter, then it could revolutionize our understanding of the universe. Instead of seeing dark matter as a mysterious, invisible force, we would begin to recognize it as a fundamental component of reality, one that shapes the very fabric of existence. This knowledge could lead to new theories of physics, new technologies, and even new ways of thinking about life, consciousness, and the nature of reality itself. But perhaps the most profound implication of all is what this means for the future of humanity. If we can learn to manipulate dark matter waves, then we might gain access to an entirely new level of control over the universe. Imagine a future where we could harness the power of dark matter to create energy, bend gravity, or even alter the flow of time. This would not just be a scientific breakthrough, it would be a transformation of what it means to be human. And yet, with such power comes great responsibility. If dark matter is truly fundamental to the structure of the universe, then any attempt to manipulate it could have consequences beyond our understanding. Just as splitting the atom led to both nuclear energy and nuclear weapons, unlocking the secrets of dark matter could lead to both incredible advancements and unimaginable dangers. So, as we stand on the edge of this great unknown, we must ask ourselves, are we ready for what we might discover? The mysteries of dark matter are vast and complex, and the answers we seek may challenge everything we think we know. But one thing is certain, the journey to understand fuzzy dark matter is not just a scientific quest. It is a journey into the deepest secrets of the cosmos, a search for the hidden forces that shape our universe, and perhaps, a glimpse into the very nature of existence itself. If fuzzy dark matter is truly the missing piece of the cosmic puzzle, then its discovery could be as transformative as the realization that the Earth orbits the Sun or that space and time are interconnected. It would redefine physics, astronomy, and even philosophy. But the question remains, how do we prove its existence? Since fuzzy dark matter doesn't interact with light or conventional matter in any noticeable way, we are left to detect its influence indirectly, through its gravitational effects or its possible impact on quantum systems. One of the strongest arguments in favor of fuzzy dark matter is the structure of galaxies themselves. If dark matter were made of traditional particles, like WIMPs, weakly interacting massive particles, then we would expect galaxy cores to be denser and more compact than what we observe. But astronomers have found that galaxies often have a smooth, spread-out core, which fits perfectly with the idea of dark matter behaving like a wave rather than a collection of discrete particles. If fuzzy dark matter exists as a quantum wave, then it naturally prevents the formation of sharp, dense regions, creating the softer, more dispersed structures that we actually see in space. This hypothesis has been tested using computer simulations, where scientists create artificial galaxies with different types of dark matter and compare them to real observations. When they model dark matter as a wave-like field rather than as individual particles, the galaxies that form in their simulations closely resemble those in the real universe. The smoothness of galactic cores, the rotation speeds of stars, and the way matter clumps together all seem to align more with a wave-like dark matter than with conventional particle-based models. But if fuzzy dark matter exists, it should also leave behind more subtle fingerprints, ones that we might be able to detect with the right technology. One of the most promising ways to search for these clues is through gravitational lensing. This is the phenomenon where massive objects bend the path of light, warping the images of distant galaxies behind them. If dark matter is truly wave-like, then its distribution should create tiny, flickering distortions in these lensing patterns, distortions that would not occur if dark matter were made of heavy particles. Researchers have already begun analyzing gravitational lensing data from space telescopes, looking for these telltale distortions. If they can find patterns that match what we would expect from a wave-like dark matter field, it could provide the strongest evidence yet that fuzzy dark matter is real. However, this is an incredibly difficult task. The universe is filled with countless sources of gravitational lensing, and isolating the effects of dark matter waves from other distortions, such as the influence of stars, black holes, and intergalactic dust, is a monumental challenge. Another way to test the existence of fuzzy dark matter is to look for oscillations in the motion of stars. If dark matter behaves like a giant, oscillating quantum field, then it might cause stars to experience tiny, rhythmic shifts in their positions over time. These shifts would be so small that they would be undetectable with most telescopes, but with advanced observational techniques, such as precision astrometry, we might be able to catch them in the act. NASA's Gaia mission, which is mapping the precise positions and motions of over 1 billion stars in our galaxy, could provide valuable data for this search. If scientists detect unexplained wobbles in the movements of certain stars, wobbles that cannot be explained by planets, black holes, or gravitational waves, then it could be a sign that they are being influenced by the fluctuations of fuzzy dark matter. And what if we could go even deeper? Some physicists have proposed that dark matter waves might influence fundamental quantum processes, causing tiny variations in atomic clocks, particle interactions, or even the behavior of vacuum energy. If this is true, then laboratory experiments on Earth could provide another way to test the theory. Researchers are already working on ultra-sensitive detectors that can measure these effects, using superconducting circuits, laser interferometers, and atomic sensors to search for tiny distortions that could be caused by passing dark matter waves. But even if we prove that dark matter is wave-like, there is still another question: what exactly is it made of? The most popular candidate is the axion, a hypothetical ultralight particle that was originally proposed to solve a completely different problem in physics, the Strong's CP problem in quantum chromodynamics. Axions were first introduced as a way to explain why the laws of physics appear to treat matter and antimatter slightly differently in certain conditions, but later, scientists realized that if axions exist, they could also serve as a perfect candidate for dark matter. If axions are real, then they could be constantly streaming through space, forming a vast, invisible ocean of quantum waves that permeates the cosmos. These waves would be incredibly weak, but under the right conditions, they could interact with electromagnetic fields in subtle ways. This means that, in theory, axions could be detected using specialized experiments designed to pick up their faint interactions with radio waves, magnetic fields, or photons. One of the most ambitious experiments searching for axions is the Axion Dark Matter Experiment, ADMEX, which uses a highly sensitive radio receiver placed inside a powerful magnetic field to try to catch axions converting into photons. If ADMEX detects a signal that matches what we expect from axions, it would be one of the biggest discoveries in the history of physics. Other experiments, such as the CERN Axion Solar Telescope, CAST, and the proposed IXO, International Axion Observatory, are also searching for axions in different ways, looking for their influence in the Sun, neutron stars, and high-energy cosmic events. But what if fuzzy dark matter is not made of axions? Some scientists have proposed alternative theories, suggesting that dark matter could be a different type of ultralight boson, or even a more exotic form of energy that we do not yet understand. Some have even speculated that dark matter waves could be connected to higher dimensions or hidden aspects of quantum gravity, hinting at a deeper level of reality beyond what our current theories can describe. If this is true, then discovering the true nature of fuzzy dark matter could lead to breakthroughs that go far beyond cosmology. It could provide insights into the fundamental nature of space and time, uncover connections between quantum mechanics and gravity, and perhaps even open the door to new forms of technology that we can barely imagine today. Imagine a future where we can manipulate dark matter waves in the same way that we currently manipulate electromagnetic waves. If we could harness the properties of these quantum fields, we might be able to develop technologies that could control gravity, create new forms of energy, or even manipulate the structure of space itself. This could lead to advancements in propulsion systems, allowing us to travel through space in ways that seem impossible today. It could even lead to breakthroughs in artificial intelligence, computation, or consciousness itself, as we begin to understand how dark matter waves might influence the fundamental nature of information and perception. But with such knowledge comes great responsibility. If dark matter is truly the scaffolding of the universe, then any attempt to manipulate it could have consequences beyond our comprehension. Just as our understanding of nuclear physics led to both energy and destruction, unlocking the secrets of fuzzy dark matter could be a double-edged sword. We might gain unprecedented control over the universe, or we might unleash forces that we are not prepared to handle. As we stand at the threshold of discovery, we must ask ourselves, are we ready for what we might uncover? The universe is full of mysteries, but some secrets may be hidden for a reason. If fuzzy dark matter is truly the foundation of reality, then understanding it may not just change science, it may change everything. If fuzzy dark matter truly holds the key to the structure of the universe, then unraveling its mysteries could redefine everything we think we know about physics. But one of the biggest questions still remains: how did it come into existence in the first place? If dark matter is real, and if it's made of these ultralight quantum waves, then where did it come from? Did it form during the Big Bang, or does it predate the universe itself? Could it be linked to other fundamental forces? Or is it something entirely separate, an invisible cosmic ocean that has always existed, shaping the universe from behind the scenes? To answer this, we need to look at the earliest moments of the universe, a time when space, time, and matter were in a state of unimaginable chaos. In the first fractions of a second after the Big Bang, the universe was so hot and dense that normal matter as we know it couldn't exist. Instead, everything was an energetic plasma of fundamental particles, colliding and interacting in ways that are still not fully understood. During this period, physicists believe that different forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, were not separate, but unified in a single, all-encompassing force. As the universe expanded and cooled, these forces began to separate, forming the familiar laws of physics that govern our world today. It is during this phase that dark matter, if it exists, must have emerged. But how? If fuzzy dark matter is made of axions or similar ultralight particles, then they may have been produced in massive numbers as the universe transitioned from its high-energy primordial state to the more stable cosmos we see today. These particles, unlike normal matter, wouldn't have interacted with light or other forces in any significant way. Instead, they would have simply spread out across the universe, forming a vast, invisible framework that shaped the evolution of galaxies, stars, and planets. But there's another possibility. What if dark matter didn't originate in the early universe at all? Some physicists have suggested that it could be a remnant of a previous universe, something that survived the end of a cosmic cycle and carried over into our own reality. If true, this would mean that fuzzy dark matter is not just a product of our universe, but a fundamental aspect of reality itself, something that exists beyond time and space as we understand them. This idea connects to one of the most intriguing theories in modern physics, cyclic cosmology. Instead of the universe having a single beginning and expanding forever, some models suggest that the universe goes through endless cycles of expansion and contraction. Each cycle ends in a kind of cosmic rebirth, where a new universe emerges from the ashes of the old one. If this is true, then dark matter might be the one thing that carries over from cycle to cycle, persisting through the death and rebirth of the cosmos like an eternal, invisible force. And if that's the case, then what does that say about reality itself? If dark matter exists beyond the lifespan of individual universes, could it be connected to something even deeper, a hidden layer of the cosmos that we have yet to discover? Some scientists have speculated that dark matter waves might be linked to hidden dimensions, extra layers of space beyond the three we can see. String theory, one of the leading candidates for a theory of everything, suggests that the universe may have multiple hidden dimensions curled up at microscopic scales. If dark matter interacts with these dimensions in some way, it could explain why it behaves so differently from normal matter, and why it appears to be completely invisible except for its gravitational effects. If we could prove that fuzzy dark matter is connected to extra dimensions, it would revolutionize physics. It could provide the first direct evidence that our universe is only a small part of a much larger, more complex reality. It could even hint at the existence of parallel universes, where the rules of physics are different, and where dark matter might behave in ways that are completely alien to us. But how would we even begin to test such an idea? If dark matter is connected to extra dimensions, then it might leave behind subtle effects that we can detect. For example, if dark matter waves interact with higher dimensions, they might create tiny, fluctuating gravitational forces that could be measured with ultra-sensitive detectors. Some scientists have proposed using powerful lasers, massive underground detectors, or even experiments in space to search for these effects. And then there's the question of time. If dark matter is truly wave-like, then could it be influencing time itself? Some researchers have suggested that dark matter might subtly affect the passage of time, creating tiny distortions in the way clocks tick in different parts of the universe. If we could measure these distortions, it might provide another way to confirm the existence of fuzzy dark matter and understand its deeper nature. But perhaps the most unsettling possibility is that dark matter might not just be an invisible framework for the universe. It might be alive in some way. Not alive in the biological sense, but in the sense that it might have its own form of self-organization, its own patterns and rules that we have yet to understand. Some physicists have speculated that dark matter waves could form structures that resemble neural networks, complex systems that store and process information in ways that we don't yet recognize. If this is true, then it raises an even bigger question: could dark matter itself be conscious? Could the universe have its own hidden form of awareness, something that exists on a level beyond our understanding? While this idea is purely speculative, it is not entirely outside the realm of possibility. If dark matter is a quantum wave, and if quantum waves are capable of carrying and processing information, then who's to say that dark matter isn't playing a role in the deeper workings of reality? If we ever prove that dark matter has some form of intrinsic intelligence, it would completely change our understanding of the universe and our place in it. It would mean that we are not just living inside a cold, lifeless cosmos, but within something far stranger and more mysterious, something that may have its own form of awareness, its own hidden logic that we have yet to uncover. And that brings us to the ultimate question: if dark matter is conscious, then could we ever communicate with it? Could we develop a way to tap into the hidden structure of the universe and access knowledge that has been encoded in dark matter waves since the beginning of time? If we could, then it would be the most profound discovery in the history of science. It would mean that the universe itself might be a kind of living entity, an unimaginable intelligence woven into the very fabric of reality. It would mean that the answers to the biggest questions: what is the nature of existence? What happens after death? What is the ultimate fate of the universe? Might already be encoded in the cosmic waves that surround us. But for now, we are left with more questions than answers. Fuzzy dark matter remains one of the greatest mysteries in the cosmos, a puzzle that could unlock secrets beyond anything we have ever imagined. And perhaps, in the distant future, when we finally unravel its mysteries, we will discover that reality is far stranger and far more wondrous than we ever thought possible. If fuzzy dark matter truly holds the key to understanding the universe, then solving its mysteries might not just answer fundamental physics questions, it could redefine our understanding of reality itself. But there's something even more puzzling about it. If these quantum waves of dark matter have existed since the dawn of time, shaping galaxies and influencing cosmic structures, could they also be influencing us in ways we don't yet understand? Could dark matter, in some strange and unexpected way, be connected to human consciousness? This is not as far-fetched as it might seem. In the world of quantum physics, particles do not behave in predictable ways like objects in classical physics. Instead, they exist in superpositions of states, only choosing a definite state when observed. If fuzzy dark matter is truly a wave-like phenomenon on cosmic scales, then could it be interacting with other quantum systems in ways we haven't yet detected? Could it be subtly influencing the fundamental processes of the brain? Some physicists and neuroscientists have explored the idea that consciousness itself might have quantum origins. If the brain relies on quantum processes to function, something that is still highly debated, then there is a possibility that dark matter waves, stretching across the universe, could be affecting our minds in subtle ways. This would mean that we are not entirely separate from the cosmos, but rather, deeply entangled with it in ways we don't yet comprehend. If this is true, then it could mean that our thoughts, memories, and even our perception of reality are subtly shaped by an invisible structure that permeates the universe. Could this be why certain phenomena, like déjà vu or intuition, feel so mysterious? Could dark matter waves be subtly influencing the way our brains process time, space, and even consciousness itself? While there is no concrete evidence for this yet, the possibility is intriguing. But let's go even deeper. If dark matter is truly wave-like, then could it store information? Could it act as a kind of cosmic memory, preserving patterns from the past and subtly influencing the future? In standard physics, information is never truly lost. It is always encoded in some form, even if it appears to be erased. If fuzzy dark matter is spread throughout the universe as an enormous, undetectable quantum wave, then could it be carrying imprints of everything that has ever happened? This leads to an even wilder possibility. Some physicists have suggested that the universe itself might be a kind of simulation, where reality is built on underlying quantum information rather than solid matter. If this is true, then dark matter could be part of the coding system of the universe, the invisible framework that holds everything together while remaining just out of reach of our detection. If that sounds crazy, consider this. In recent years, researchers have discovered strange mathematical structures in physics that suggest reality may be fundamentally made of information rather than physical objects. Some theories propose that space-time itself emerges from underlying quantum entanglement, a web of interconnected information that gives rise to what we perceive as reality. If this is true, then dark matter could be a missing piece of this puzzle, an invisible component of the universe's hidden code. And if that's the case, then what does it mean for us? Could we ever tap into this hidden structure? Could we learn to interact with dark matter, not just as scientists studying the cosmos, but as beings trying to understand our own existence? If dark matter is a fundamental aspect of reality, then unlocking its secrets could lead to technological advancements beyond anything we can imagine. Perhaps even a way to manipulate gravity, bend space-time, or tap into an invisible form of cosmic energy. Some researchers have proposed that, in the far future, advanced civilizations might learn to harness dark matter for unimaginable purposes. If dark matter waves stretch across galaxies, then could they be used for faster-than-light communication? Could they serve as a medium for transmitting information across vast distances without the limitations of traditional physics? If so, then perhaps alien civilizations, if they exist, have already discovered a way to use dark matter as a means of interstellar contact, something we are just beginning to explore. This raises an even more unsettling possibility. If advanced civilizations have already learned to manipulate dark matter, then could they be using it to observe us? Could the strange, undetectable nature of dark matter be the reason why we have yet to find definitive proof of extraterrestrial life? If an alien civilization had technology capable of harnessing dark matter waves, they might be able to move through the cosmos unseen, existing in a way that is completely undetectable to our instruments. And then there's the question of time itself. If dark matter is truly a quantum phenomenon, then could it be connected to time in ways we don't yet understand? Some researchers have speculated that dark matter could play a role in the arrow of time, the reason why time seems to flow in one direction, from past to future. If we ever learn to manipulate dark matter, then could we learn to influence time itself? Could dark matter hold the key to time travel, or at least, to a deeper understanding of how time truly works? Perhaps the most mind-bending possibility of all is that dark matter, rather than being a passive component of the universe, might actually be playing an active role in shaping reality. If dark matter waves are influencing the formation of galaxies and cosmic structures, then could they also be shaping events on smaller scales? Some scientists have even speculated that dark matter could be linked to the concept of fate itself. If the universe is fundamentally built on quantum information, and if dark matter is an essential part of that structure, then could our lives, our choices, our experiences, our very thoughts, be subtly guided by an unseen force? Could dark matter be influencing the probability of events, nudging reality in ways we don't yet understand? This idea is, of course, purely speculative. But it raises deep questions about the nature of existence. If dark matter is truly a hidden, fundamental part of the universe, then unlocking its secrets could change everything we know about reality. It could reveal that the universe is far more interconnected, far more mysterious, and far more alive than we ever imagined. And perhaps, one day in the distant future, when we finally understand the true nature of dark matter, we will realize that it was never truly dark at all. It was always there, shaping the cosmos, shaping our world, and maybe even shaping us in ways we never knew. If dark matter is not just an invisible, passive substance but an active player in the grand design of the universe, then we are faced with a truly staggering realization. It means that everything we know, every law of physics, every fundamental assumption about space and time, could be missing a critical piece of the puzzle. What if dark matter is more than just a mysterious cosmic glue? What if it is the fabric of something even deeper, something that lies at the core of reality itself? Some physicists have started to entertain a radical possibility that dark matter, rather than being just an exotic form of matter, is actually a sign of a hidden layer of reality. If fuzzy dark matter is a quantum wave that stretches across vast distances, then what if it is part of a larger, undetected structure? Some have proposed that dark matter could be evidence of extra dimensions, hidden layers of space that we cannot perceive directly. In this scenario, the reason we cannot see dark matter is not because it is truly invisible, but because it exists partially outside of our three-dimensional universe. Imagine for a moment that the universe we experience is like a two-dimensional surface floating in a vast, higher-dimensional space. We can only move in the dimensions we know, length, width, and height, but there could be additional dimensions curled up beyond our perception. In these hidden dimensions, dark matter could be moving, flowing, and even interacting in ways we cannot comprehend. If this is true, then fuzzy dark matter might not just be an ordinary substance. It could be the first tangible evidence of an entire hidden reality, a cosmic shadow of a larger universe just beyond our grasp. But what if dark matter is even stranger than that? Some researchers have speculated that dark matter could be a form of ghost matter, something that exists in a parallel reality, one that overlaps with our own but remains just out of reach. If dark matter particles behave like waves, then could it be that they are flickering in and out of existence, shifting between different states of reality? Could dark matter be moving between our universe and another, existing in a way that defies conventional understanding? This idea might sound like science fiction, but it is rooted in real physics. In quantum mechanics, particles can exist in multiple states at once, only collapsing into a definite state when observed. If dark matter is truly a quantum phenomenon on cosmic scales, then it might not be entirely bound to our universe. It might exist in a kind of limbo, straddling multiple realities at the same time. And if that is true, then could there be a way to tap into it? Could we one day learn to manipulate dark matter, to access this hidden layer of reality? If dark matter holds the key to another realm, then what does that mean for the nature of the universe? Could there be an entire hidden cosmos, a mirror universe where dark matter is visible and ordinary matter is the strange, undetectable force? Some theories suggest that dark matter could be part of a shadow universe, one that exists parallel to our own, governed by its own laws of physics. If this is true, then could dark matter be the first sign of a vast, unseen world, a realm that exists alongside ours, influencing it in ways we don't yet understand? And if there is a shadow universe, then what else might exist within it? Could there be unknown forms of life, strange beings that exist in a reality where dark matter is the dominant force? If dark matter is truly an essential part of the cosmos, then it might not just shape galaxies. It could shape the very fabric of life itself. What if there are entire civilizations, hidden within the folds of dark matter, living in a reality we cannot perceive? This might sound far-fetched, but consider this: dark matter makes up most of the universe, yet we cannot see it, touch it, or interact with it directly. It is a ghostly presence, shaping the cosmos from the shadows. If intelligent beings existed within a dark matter-based reality, they might be just as puzzled by ordinary matter as we are by dark matter. To them, we might be the invisible ones, the strange, unknowable entities that exist in a parallel dimension, beyond their reach. But what if there is a way to bridge the gap? If dark matter is truly a quantum wave, then could it be possible to manipulate it, to generate signals that cross between these hidden layers of reality? If dark matter is connected to higher dimensions, then could advanced civilizations have already discovered a way to travel through them? Could this be the answer to one of the greatest questions in science: why we have not yet encountered extraterrestrial life? Some have suggested that if aliens exist, they might have evolved to use dark matter as a means of travel, moving through the universe in ways we cannot detect. If dark matter can interact with itself in ways we do not yet understand, then perhaps advanced beings have found a way to exploit this, creating technologies that allow them to slip between dimensions, bypassing the limitations of conventional space travel. If this is true, then we might never see them, because they are not moving through ordinary space, but through a hidden structure that we cannot yet access. And that leads to an even bigger question. If dark matter is the key to hidden dimensions, then could it be the key to understanding time itself? Some physicists believe that dark matter might play a role in the fundamental nature of time, influencing the way time flows on cosmic scales. If dark matter is connected to quantum mechanics, then could it be part of the reason why time appears to move forward, rather than backward? Could dark matter be subtly shaping the passage of time, creating the illusion of a one-way arrow when in reality, time is far more fluid than we perceive? This idea is not as strange as it sounds. In quantum physics, time does not necessarily have a preferred direction. On small scales, the equations work just as well forward as they do backward. But in our everyday experience, time moves in one direction, from past to future. If dark matter is interacting with space-time in some hidden way, then could it be responsible for creating this effect? Could the wave-like nature of fuzzy dark matter be subtly guiding the flow of time, shaping the way we experience reality? And if dark matter is connected to time, then what happens if we learn to manipulate it? Could controlling dark matter allow us to slow down time, or even reverse it? If dark matter is linked to the deeper structure of the universe, then understanding it might open doors we never even imagined. It might allow us to reshape the very nature of existence, to bend the rules of reality in ways that were once thought impossible. The deeper we dig into the mystery of dark matter, the more it seems like it is not just a missing piece of physics. It might be the foundation of something much greater. If we ever unlock its secrets, we might not just learn about the cosmos, we might learn about the true nature of reality itself. If dark matter holds the key to understanding reality at a deeper level, then it might not be just another component of the universe. It might be the foundation upon which everything is built. What if dark matter is not just an invisible form of matter, but something far more fundamental? Some physicists have started to ask whether dark matter is actually a manifestation of a deeper, unknown layer of physics, one that underlies not just the universe we see, but the very nature of existence itself. If fuzzy dark matter is truly a wave, stretching across vast cosmic distances, then could it be connected to the very fabric of space-time? There is an idea in physics that space is not empty. Even in a vacuum, where there are no particles, something still exists, a field of energy that permeates everything. This concept, known as the quantum vacuum, suggests that empty space is never truly empty. It is a seething sea of virtual particles, flickering in and out of existence at the smallest possible scales. Could dark matter be connected to this hidden energy field? If fuzzy dark matter is a quantum wave, then could it be part of the quantum vacuum itself, a sign that space is not just a void, but an active, dynamic medium? If dark matter is linked to the quantum vacuum, then it could be more than just a missing form of matter. It could be the missing link between gravity and quantum mechanics, the two great pillars of physics that have never quite fit together. For decades, physicists have struggled to unify these two theories. Gravity, as described by Einstein's general relativity, is the force that shapes the universe on the largest scales. Quantum mechanics, on the other hand, governs the behavior of particles at the smallest scales. The problem is that these two theories contradict each other in fundamental ways. But what if dark matter is the bridge between them? Some researchers believe that dark matter could be a manifestation of quantum gravity, a sign that gravity itself is not what we think it is. In this view, gravity might not be a fundamental force at all, but an emergent phenomenon, arising from the collective behavior of countless microscopic quantum interactions. If this is true, then dark matter might not be a separate type of matter at all. It could be a sign that space itself has an underlying, quantum structure. This idea is radical, but it has precedent. In recent years, some physicists have suggested that space-time might emerge from a deeper, more fundamental layer of physics, just as temperature emerges from the motion of individual atoms. If space and time are not fundamental, but instead arise from a deeper quantum reality, then dark matter could be a clue to how this process works. Could dark matter be a sign that the universe itself is built from a hidden, quantum code, one that we have only just begun to uncover? And if dark matter is connected to the deeper structure of reality, then could it be possible to manipulate it? If dark matter is a wave, then could we one day learn to control it, to shape the universe in ways that seem impossible by today's standards? Some have speculated that if dark matter is a quantum wave, then it might be possible to use it to create new forms of technology, perhaps even a new form of propulsion, one that could allow us to travel the cosmos without the need for conventional fuel. If dark matter is connected to hidden dimensions, then could it be the key to interdimensional travel? If this sounds like science fiction, consider this. We already know that space itself can be bent and warped. In Einstein's theory of relativity, massive objects like stars and black holes distort the fabric of space-time, creating the effect we experience as gravity. But what if there was a way to manipulate space itself? What if dark matter, with its strange wave-like nature, could be the tool that allows us to bend space at will? Some researchers have speculated that if we could understand dark matter deeply enough, we might be able to create artificial distortions in space-time, perhaps even allowing for faster-than-light travel. This is not just wild speculation. Some physicists are already exploring the possibility of using quantum fields to manipulate space. If dark matter is a quantum wave, then it might be possible to use its properties to create a new kind of energy field, one that could bend spacetime in ways we do not yet fully understand. If this is possible, then it could open the door to entirely new forms of technology, perhaps even the ability to create stable wormholes, shortcuts through space that could allow us to travel vast distances instantly. But if dark matter is connected to a hidden structure of reality, then what else might it reveal? Could it be that dark matter is not just a missing component of the universe, but a sign that the universe itself is part of something much larger? Some cosmologists have suggested that our universe might be just one of many, a bubble in a vast multiverse, where different regions of space have different physical laws. If this is true, then could dark matter be the first sign of another universe interacting with our own? One of the strangest ideas in modern physics is the possibility that our universe is not alone. Some theories suggest that multiple universes could exist side by side, each with its own unique properties. If this is true, then dark matter could be the shadow of another universe, a sign that we are not isolated, but part of a much larger, interconnected reality. If dark matter particles are behaving like waves, then could they be leaking in from another universe, subtly influencing our cosmos from the outside? And if dark matter is a bridge between universes, then what does that mean for the nature of reality itself? Could it be that dark matter is not just an invisible force, but a sign that the universe is far stranger than we ever imagined? If we ever unlock the secrets of dark matter, we might not just learn about the cosmos. We might learn that reality itself is far more complex, far more mysterious, and far more profound than we ever thought possible. If dark matter is truly the key to understanding the deeper layers of reality, then the implications could be staggering. For decades, we've been searching for a grand unified theory, a single framework that explains everything from the smallest particles to the largest structures in the cosmos. But what if we've been looking in the wrong place? What if the answer has been hidden in the very thing we've been struggling to understand, dark matter? Fuzzy dark matter challenges our conventional understanding because it behaves more like a field than a collection of particles. If we could understand how these waves interact with normal matter, we might uncover the fundamental rules that govern not just dark matter, but reality itself. The very fact that fuzzy dark matter doesn't behave like ordinary particles suggests that it might belong to an entirely different class of physics, one that we haven't yet fully explored. Some physicists have speculated that dark matter could be related to a deeper, hidden symmetry of the universe. In physics, symmetry is a powerful concept. It describes how certain properties of nature remain unchanged under various transformations. The laws of physics, for example, don't change if you rotate your position in space or move at a constant velocity. These symmetries are tied to fundamental forces, like electromagnetism and gravity. But could dark matter hint at a deeper, hidden symmetry, one that connects forces in ways we don't yet understand? One of the most exciting possibilities is that dark matter could be linked to the unification of forces. Right now, we know that 3 of the 4 fundamental forces, electromagnetism, the weak nuclear force, and the strong nuclear force, are related under what's known as the standard model of particle physics. But gravity has never fit into this model. The problem is that gravity is vastly weaker than the other forces, and nobody knows why. Some theorists have proposed that gravity's weakness might be due to extra dimensions, hidden layers of reality beyond our normal three-dimensional space. Fuzzy dark matter, with its wave-like nature, could be a sign that these extra dimensions are real. If dark matter exists in higher dimensional space, then we might only be seeing a projection of its true form in our three-dimensional world. This could explain why dark matter behaves so differently from ordinary matter. It might not even be fully contained within our universe as we understand it. And if dark matter exists in higher dimensions, then it could open up new possibilities for understanding the fundamental structure of the cosmos. Could it be that dark matter is actually a form of energy that leaks into our universe from a hidden dimension? Some researchers have speculated that dark matter could be a type of shadow matter, a substance that exists in a parallel realm but interacts with our universe through subtle gravitational effects. If this is true, then dark matter could be the first real evidence that extra dimensions exist. But if dark matter is a clue to a hidden structure of the universe, then what else could it reveal? Could it be that our universe is not just a vast expanse of space, but part of something even larger, perhaps a vast, interconnected web of realities? Some theories propose that our universe is just one of many, a single bubble in a much larger multiverse. If dark matter is linked to these other universes, then we might be seeing evidence of a hidden cosmic architecture, one that stretches beyond anything we can currently observe. And if dark matter is connected to hidden dimensions, then what does that mean for the nature of time itself? Some physicists believe that time is not a fundamental property of the universe, but something that emerges from deeper quantum interactions. If this is true, then dark matter could play a role in shaping the flow of time in ways we don't yet understand. Could it be that dark matter holds the key to unlocking the true nature of time, perhaps even allowing us to manipulate it? This might sound like science fiction, but there are already theories that suggest time is far more flexible than we once thought. In Einstein's theory of relativity, time is not absolute. It can stretch and contract depending on the strength of gravity and the speed at which an observer is moving. If dark matter interacts with space-time in unexpected ways, then it could reveal entirely new ways of thinking about time, perhaps even suggesting that time itself is not a fixed, linear progression, but something that can be warped, bent, or even reversed under the right conditions. And if dark matter is linked to the deeper structure of reality, then could it also be linked to the origins of the universe itself? One of the biggest mysteries in cosmology is what happened before the Big Bang. According to our current understanding, the universe began as an incredibly hot, dense point that suddenly expanded in an event known as cosmic inflation. But what caused the Big Bang in the first place? And could dark matter have played a role? Some researchers believe that dark matter could be a remnant of a previous universe, something that existed before the Big Bang and carried over into our own cosmos. If dark matter is a wave-like field, then it might have existed in a different state before the birth of our universe, only to become what we now observe after the Big Bang. This could mean that dark matter holds a record of the universe's earliest moments, a kind of cosmic memory encoded in the structure of space itself. And if dark matter is connected to a previous universe, then could it also be a sign that the Big Bang was not a one-time event? Some theories suggest that the universe undergoes cycles of expansion and contraction, with each cycle leading to a new Big Bang. If this is true, then dark matter could be the thread that connects one universe to the next, a sign that reality is not just a single event, but an endless, repeating pattern stretching across eternity. But if dark matter is the key to understanding the structure of reality, then what does that mean for the future of the universe? Could dark matter hold clues about the ultimate fate of everything? Right now, we know that the universe is expanding, and that dark energy, a mysterious force that accelerates this expansion, is driving galaxies apart at an ever-increasing rate. But what role does dark matter play in this process? If dark matter is a wave, then could it eventually decay or change into something else? Some researchers have proposed that dark matter might not be stable forever, that over trillions of years, it could transform into a different form of energy, altering the balance of the cosmos. If this is true, then the long-term fate of the universe might be very different from what we currently predict. Instead of expanding forever or collapsing in a big crunch, the universe might undergo a radical transformation, one driven by the hidden physics of dark matter. And if dark matter is connected to the quantum fabric of reality, then could it one day be harnessed for technology? Right now, we have no way of directly interacting with dark matter, but if it is truly a quantum wave, then could we find a way to manipulate it? If we could control dark matter, then we might be able to create new forms of energy, develop new methods of space travel, or even unlock secrets about the nature of consciousness itself. Some theories suggest that the human mind is deeply connected to the quantum world, and if dark matter is a quantum phenomenon, then could it have a hidden connection to the way we perceive reality? Could dark matter waves interact with consciousness in ways we don't yet understand? If this is true, then dark matter might not just be a physical mystery. It could be a sign that the very act of observation, the way we experience the world, is linked to something much deeper than we ever imagined. The mystery of dark matter is not just about understanding the missing mass of the universe. It is about unlocking the fundamental nature of reality itself. If fuzzy dark matter is real, then it could be the first glimpse of a hidden structure of the cosmos, one that could change everything we think we know about space, time, and existence. If fuzzy dark matter is truly a glimpse into a deeper structure of the universe, then we might be standing at the edge of a revolution in physics. One that could change everything from our understanding of the cosmos to the very nature of reality itself. But here's the most mind-bending part. If fuzzy dark matter is a wave-like entity that spans across galaxies, then it might not just be a passive substance that fills space. It could be actively shaping the structure of the universe in ways we don't yet understand. One of the biggest mysteries in cosmology is why galaxies form the way they do. If you look at a spiral galaxy, you'll notice that its arms maintain their shape even though they are spinning. According to classical physics, this shouldn't happen. If galaxies were made only of normal matter, then the outer stars should be flung away due to centrifugal force, just like water droplets fly off a spinning wheel. But they don't. Instead, something invisible is holding them together, something massive, yet undetectable. That's dark matter. But if dark matter is fuzzy dark matter, then it's not just sitting there like a static cloud of mass. It's constantly oscillating, behaving like a massive, slow-moving quantum wave. And if that's true, then it might be actively influencing how galaxies form, evolve, and even how they interact with one another. Imagine an invisible ocean of dark matter waves rippling across the cosmos, subtly guiding the motion of galaxies like ocean currents, shaping islands. This could explain one of the greatest cosmic puzzles, why galaxies tend to form along vast, web-like structures known as the cosmic web. When astronomers map out the large-scale structure of the universe, they don't see galaxies evenly distributed in space. Instead, they see massive clusters of galaxies connected by filaments of matter, forming a web-like pattern that spans billions of light-years. Scientists believe this structure was influenced by dark matter. But if dark matter is a quantum wave, then these filaments might not just be shaped by gravity. They could be shaped by interference patterns created by the overlapping waves of fuzzy dark matter. Think about how sound waves can create patterns in sand when they pass through a surface. If dark matter behaves like a wave, then it could be doing something similar on a cosmic scale, creating interference patterns that guide the formation of galaxies, determining where matter can cluster and where it cannot. This would mean that the universe's structure isn't just a result of random gravitational attraction, but a carefully orchestrated symphony of quantum waves stretching across billions of light years. But here's where things get even stranger. If dark matter is made of ultralight particles behaving like a wave, then those waves must have a frequency. And if they have a frequency, then they might be interacting with other quantum fields in ways we haven't yet realized. Could it be that fuzzy dark matter is influencing the very laws of physics in different regions of the universe? Right now, we assume that the fundamental constants of physics, things like the speed of light, the strength of gravity, and the charge of the electron, are the same everywhere in the universe. But what if they aren't? What if fuzzy dark matter subtly alters these constants in different parts of space? If that's true, then physics might not be as universal as we think. The laws of nature we experience here on Earth might be slightly different from those in a distant galaxy, all because of the way dark matter waves interact with the underlying fabric of space-time. And if fuzzy dark matter can influence physical constants, then could it also be affecting time itself? Right now, we think of time as a dimension, similar to space, that moves in one direction. But quantum mechanics suggests that time might be more fluid than we realize. If fuzzy dark matter creates wave-like patterns in space, then could it also be creating patterns in time? Could it be that time flows differently in regions with different densities of dark matter? This might not be as far-fetched as it sounds. In Einstein's theory of relativity, time slows down in strong gravitational fields. If dark matter creates additional fluctuations in space-time, then it could also create tiny distortions in the passage of time. Distortions that are too small for us to notice but that could have profound implications on a cosmic scale. If this is true, then dark matter might not just be shaping galaxies, it might be shaping the flow of time itself. It might be responsible for the way time unfolds differently in different parts of the universe, leading to strange effects that we've only just begun to explore. And here's where things take an even wilder turn. If fuzzy dark matter is a wave, then it must have an associated wavelength. In quantum mechanics, wavelengths are tied to the size of the system they describe. The smaller the particle, the shorter its wavelength. But because fuzzy dark matter is incredibly light, its wavelength is enormous, potentially spanning entire galaxies. This means that fuzzy dark matter could be entangled across vast cosmic distances. In quantum mechanics, entanglement is a phenomenon where two particles become linked, no matter how far apart they are. If fuzzy dark matter has a wavelength large enough to span a galaxy, then could it be that entire galaxies are quantum entangled with each other through dark matter? If that's true, then our universe might be far more interconnected than we ever imagined. The motion of a galaxy billions of light years away could, in some small way, be linked to the motion of our own Milky Way. This would mean that the universe isn't just a collection of independent objects floating in space. It's a deeply connected quantum system, where changes in one part could subtly influence another through an invisible web of entanglement. And if galaxies are entangled through fuzzy dark matter, then could this explain some of the biggest cosmic mysteries we've ever encountered? Astronomers have observed strange phenomena in deep space, such as galaxies that appear to be moving in sync, even though they are millions of light years apart. Some have suggested that this could be due to a hidden force. But what if the answer is quantum entanglement through dark matter? This would mean that dark matter isn't just an invisible mass holding galaxies together, it's an active participant in the cosmic dance, linking distant objects in ways that defy classical physics. It could mean that the entire universe is, in some sense, a single, interconnected quantum entity. And if that's the case, then what does it mean for us? Could it be that our very existence is somehow influenced by this invisible field of quantum waves? If fuzzy dark matter is truly a fundamental component of reality, then it might not just be shaping galaxies, it might be shaping the very nature of life itself. What if dark matter plays a role in the emergence of consciousness? Right now, we don't fully understand how consciousness arises from the brain. Some scientists believe it's purely a result of neural activity, while others suggest that quantum effects might be involved. If dark matter is a quantum wave that pervades the entire universe, then could it also play a role in the way consciousness emerges? Could it be that the same quantum principles that govern dark matter also influence the way our minds work? If this is true, then we might be connected to the cosmos in ways we never realized. It could mean that the very thoughts we have, the very act of perceiving reality, is linked to an underlying quantum structure that stretches across the universe. If fuzzy dark matter is real, then it might not just be the key to understanding galaxies, it might be the key to understanding ourselves. If fuzzy dark matter is truly connected to the quantum structure of the universe, then we may have to rethink our entire understanding of reality itself. We have always assumed that dark matter is a passive background force, an unseen gravitational hand shaping galaxies from the shadows. But what if it's not just influencing matter? What if it's influencing the very nature of existence? If dark matter is composed of ultralight bosons behaving as a wave, then the entire cosmos could be immersed in a vast, invisible quantum field, subtly guiding the way everything unfolds, including the formation of stars, planets, and possibly even life. One of the strangest implications of fuzzy dark matter is how it might interact with ordinary matter in ways we haven't yet detected. If it oscillates like a wave, then it's possible that under the right conditions, it could interfere with atomic structures. Right now, dark matter is thought to be completely non-interacting except through gravity. But what if that's not entirely true? What if, on an extremely subtle level, fuzzy dark matter interacts with the fundamental forces of nature in ways we can't yet measure? This could mean that dark matter might not only be shaping galaxies, it might be influencing the behavior of atoms, particles, and even the quantum fields that govern reality. Think about how strange quantum mechanics already is. We know that particles can exist in superpositions, appearing to be in multiple places at once until observed. We know that entanglement allows particles to be instantly connected across vast distances, defying classical physics. Now, imagine if an enormous, galaxy-spanning quantum wave, fuzzy dark matter, was acting as an unseen player in these interactions. Could it be that dark matter plays a hidden role in quantum entanglement? Could it be that when two particles become entangled, they are actually interacting with a deeper, invisible quantum field made of dark matter? This would mean that fuzzy dark matter isn't just shaping the cosmos. It might be part of the hidden structure that binds reality together at the most fundamental level. It might be responsible for some of the deepest mysteries in quantum physics, such as wave function collapse, where a particle suddenly chooses a definite state when observed. If dark matter is present everywhere and behaves like a wave, could it be acting as a kind of cosmic observer, influencing how reality unfolds at the smallest scales? And if that's true, then we need to ask a deeper question: could dark matter be linked to time itself? Right now, we experience time as a linear flow, moving in one direction from past to future. But in physics, time is more complicated than that. Einstein's relativity shows that time is not absolute. It stretches and compresses depending on gravity and velocity. If dark matter has wave-like properties and is present everywhere, could it be influencing the way time itself flows? What if the density of dark matter in different regions of space actually alters the passage of time? In areas where dark matter is denser, time could flow slightly differently than in regions where it is more diffuse. This could explain why some galaxies appear to be older than they should be based on our current models. Perhaps time itself has been affected by waves of dark matter fluctuating through space. If this is true, then fuzzy dark matter isn't just a missing piece of the puzzle. It might be the key to understanding why time moves the way it does. Now, let's take this even further. If dark matter can influence time, then could it also be linked to the phenomenon of consciousness? Right now, we don't know why consciousness exists. We experience thoughts, emotions, and self-awareness, but there is no definitive explanation for why a collection of neurons in our brains gives rise to the feeling of being alive. Some researchers have suggested that consciousness may have a quantum component, that it arises not just from chemical reactions but from quantum effects within the brain. If this is true, and if dark matter is an all-encompassing quantum field, then could it be playing a role in the very essence of our awareness? It's a radical idea, but consider this: if dark matter is truly everywhere, forming a vast, oscillating wave across the cosmos, then we are not separate from it. Our bodies, our thoughts, everything we are, exists within this field. Could it be that our consciousness is somehow linked to this invisible structure? Could it be that the fluctuations of dark matter waves are subtly affecting the way we think, feel, and perceive reality? This might sound like pure speculation, but there are reasons to consider it. Some physicists believe that space itself may be a kind of emergent phenomenon, arising from deeper quantum structures. If fuzzy dark matter is a fundamental part of those structures, then it could mean that the reality we experience is built upon a hidden, oscillating framework of dark matter waves. In other words, dark matter might not just be shaping galaxies, it might be shaping the very way we perceive existence. And if that's true, then what else might dark matter be capable of? Could it hold the key to unlocking hidden dimensions of space and time? Some theories suggest that additional dimensions exist beyond the three of space and one of time that we experience. But if these dimensions are hidden, then something must be preventing us from interacting with them. Could it be that dark matter is somehow acting as a boundary between the dimensions we see and the ones we don't? If fuzzy dark matter exists as a vast, oscillating quantum wave, then it might be more than just invisible mass. It might be a doorway to deeper layers of reality. Some physicists have speculated that dark matter could be interacting with hidden forces or particles that exist beyond our current understanding. If this is the case, then studying fuzzy dark matter might not just reveal the nature of dark matter itself, it might reveal entirely new realms of physics. And if we ever do uncover the true nature of fuzzy dark matter, then it could lead to one of the greatest revolutions in science. Right now, dark matter is one of the biggest missing pieces in our understanding of the universe. But if it turns out to be a quantum wave spanning across galaxies, influencing time, consciousness, and the fabric of reality itself, then it could be the key to understanding everything. What if the secrets of the universe aren't just hidden in distant galaxies or the depths of black holes? What if the greatest mystery of all is woven into the very structure of the cosmos, hidden in plain sight, in the silent, invisible waves of dark matter rippling through space? If fuzzy dark matter is truly as fundamental as it seems, then we are only scratching the surface of its implications. What if this mysterious quantum wave isn't just shaping the universe as we know it, but is also influencing the unseen forces that govern everything, from gravity to consciousness? If it exists everywhere, rippling across galaxies, then it could be playing a hidden role in some of the biggest mysteries in physics, including the nature of black holes, the expansion of the universe, and even the fundamental structure of space-time itself. One of the strangest ideas in modern physics is that space and time might not be continuous, but instead emerge from something deeper, something more fundamental. If space itself is an emergent property of underlying quantum processes, then what if fuzzy dark matter is one of the key ingredients of that process? Imagine if the vast, unseen quantum waves of dark matter are somehow interacting with the fabric of spacetime at the smallest scales, influencing how reality itself is formed. This could explain why space appears to stretch and warp under gravity. Perhaps what we call spacetime is actually being shaped by the fluctuations of dark matter at the quantum level. This might also provide new clues about the expansion of the universe. Right now, we know that the universe is expanding, and not only that, it's expanding at an accelerating rate. The force driving this acceleration is called dark energy, but we have no idea what it actually is. Could fuzzy dark matter be linked to dark energy? If dark matter exists as a vast quantum wave, then perhaps its oscillations are not just affecting galaxies, but also influencing the rate at which space itself expands. Maybe instead of dark energy being a separate force, it could be an emergent effect of the quantum properties of dark matter on a cosmic scale. If that's true, then it could also change the way we think about the ultimate fate of the universe. Right now, there are multiple theories about how the cosmos will end. One possibility is the Big Rip, where the accelerating expansion eventually tears apart galaxies, stars, and even atoms. Another is the Big Freeze, where expansion continues forever, leaving the universe a cold, empty void. But if fuzzy dark matter is playing a role in this expansion, then perhaps the universe isn't heading toward an inevitable end. Perhaps the quantum waves of dark matter will eventually stabilize, slowing or even reversing the expansion in ways we don't yet understand. But let's go deeper. If fuzzy dark matter can interact with spacetime, then could it also interact with black holes? Black holes are some of the most mysterious objects in the universe, warping space and time so intensely that nothing, not even light, can escape. But what happens when a black hole encounters a quantum wave of dark matter? If dark matter is truly a wave, then it could interact with black holes in strange and unexpected ways. Some scientists have suggested that ultralight bosons, the particles that make up fuzzy dark matter, could accumulate around black holes, forming massive quantum structures that could alter how black holes behave. This could explain some of the weird signals we've detected from space, unexplained X-ray bursts, strange fluctuations in the orbits of stars near black holes, and even the puzzling nature of black hole mergers detected by gravitational wave observatories. If dark matter waves are interfering with black holes, they might be subtly changing how black holes grow, spin, and even merge with one another. And if that's the case, then what happens to the information that falls into a black hole? Right now, one of the biggest paradoxes in physics is the information paradox. What happens to the information of objects that fall into a black hole? According to classical physics, anything that enters a black hole is lost forever. But quantum mechanics suggests that information can't be destroyed. If fuzzy dark matter is a quantum wave surrounding black holes, could it be playing a role in preserving or even transmitting that information in ways we don't yet understand? Now, let's consider another mind-bending possibility. What if fuzzy dark matter is connected to the existence of hidden dimensions? Some theories in physics, such as string theory, suggest that there may be extra dimensions beyond the three of space and one of time that we experience. But if these dimensions exist, why can't we perceive them? Could it be that dark matter is somehow acting as a boundary between the dimensions we see and the ones we don't? If dark matter exists as an all-pervading quantum wave, then perhaps it is interacting with these hidden dimensions in ways we can't yet measure. This could mean that dark matter isn't just influencing the universe we see. It could be playing a role in shaping the unseen layers of reality itself. If fuzzy dark matter interacts with hidden dimensions, then it might hold the key to understanding some of the strangest unanswered questions in physics, such as why gravity is so much weaker than the other fundamental forces. Right now, gravity is billions of times weaker than electromagnetism, and no one knows why. Some theories suggest that gravity might be leaking into extra dimensions. But what if dark matter is the missing link? What if dark matter waves are actually carrying gravitational influences into or out of hidden dimensions, subtly altering how gravity behaves on cosmic scales? And if that's true, then it could mean that fuzzy dark matter isn't just shaping galaxies. It might be shaping the fundamental structure of reality itself. What if the entire framework of the universe is built upon these invisible, oscillating waves? Could it be that space, time, gravity, and even the very laws of physics emerge from the interactions of dark matter on a deeper level than we can currently perceive? If we ever discover the true nature of fuzzy dark matter, it could be one of the biggest scientific breakthroughs in history. It could answer some of the deepest questions we've ever asked. What is the universe made of? Why do the laws of physics work the way they do? And perhaps, most intriguingly, could dark matter be more than just a passive force? Could it be an active participant in the unfolding of the cosmos? Because if dark matter is a quantum wave pervading all of existence, then we are not separate from it. We exist within it. It surrounds us, passes through us, and may even influence us in ways we don't yet understand. Could it be that dark matter is the missing link between the cosmos and consciousness? Could it be that we are not just observers of the universe, but deeply connected to it in ways we have yet to comprehend? And if that's true, then what else might be possible? If fuzzy dark matter is more than just an invisible scaffolding for galaxies, if it is an active, dynamic force shaping the universe, then what else could it be influencing? We already suspect that it plays a role in cosmic expansion, galaxy formation, and even the behavior of black holes. But what if it also affects something much closer to home, our own solar system, our planet, and perhaps even life itself? This might sound like science fiction, but consider this: if fuzzy dark matter exists as a vast quantum wave permeating all of space, then it is passing through us right now. Unlike regular matter, which interacts through electromagnetic forces, dark matter is largely invisible and undetectable, at least by our current methods. But that doesn't mean it has no effect. It could be subtly influencing everything, from the motion of planets to the structure of subatomic particles. Could it be possible that fuzzy dark matter is even shaping the very fabric of biological processes? One of the most puzzling mysteries in science is why life exists at all. The building blocks of life, atoms, molecules, and the forces that hold them together, follow the rules of quantum mechanics. Quantum interactions are typically thought to be confined to the microscopic world, but what if dark matter is introducing quantum effects on a larger scale? Some scientists have proposed that quantum mechanics plays a role in biological systems, from the way plants conduct photosynthesis to the way birds navigate using Earth's magnetic field. If dark matter is a quantum phenomenon on a cosmic scale, then could it be subtly influencing life at a fundamental level? This could mean that dark matter is not just a passive backdrop to existence, but a key ingredient in the unfolding of the universe. If fuzzy dark matter behaves like a quantum wave, then it might have complex interactions that we have yet to discover, interactions that could extend beyond galaxies and into the fundamental processes of reality itself. Could it be that dark matter waves are influencing the fundamental constants of nature, the numbers that determine the strength of gravity, electromagnetism, and the nuclear forces? If so, then dark matter might not just be a missing piece of physics. It might be the key to understanding why the universe is the way it is. Now, let's take this a step further. If fuzzy dark matter is connected to quantum mechanics, then it might also have implications for something even more mind-bending: time itself. Time is one of the greatest mysteries in physics. Unlike space, which we can move through freely, time appears to flow in only one direction, from past to future. But why? According to general relativity, time is not absolute. It is woven into the fabric of space-time, stretching and warping under the influence of gravity. But if time is flexible, then could dark matter be playing a role in how it unfolds? Imagine if the quantum waves of fuzzy dark matter are subtly influencing the flow of time. If dark matter exists as a vast, oscillating wave, then its interactions with regular matter might introduce tiny variations in the passage of time, variations too small for us to detect with current technology. This could have profound implications. It could mean that time itself is not a uniform, continuous flow but something that fluctuates in ways we don't yet understand. Could it be that dark matter is responsible for the strange time anomalies we sometimes observe in deep space? Discrepancies in the timing of pulsars, unexplained delays in light signals, or even the puzzling way that galaxies rotate in ways that don't match our predictions? And if dark matter influences time, then what about the nature of consciousness? Right now, we have no idea how consciousness arises. The human brain is a network of electrical impulses and chemical reactions, but none of that explains how we experience thoughts, emotions, or self-awareness. Some theories suggest that consciousness emerges from the complex interactions of neurons, but others propose that it might have a quantum component. If fuzzy dark matter is a quantum wave present everywhere in the universe, then could it also be playing a role in consciousness? Could it be that our thoughts, memories, and perceptions are in some way linked to the quantum structure of dark matter? If that's true, then it would mean that dark matter is not just an invisible force shaping galaxies. It is an integral part of reality itself. It could mean that the universe is not just a collection of random particles, but a deeply interconnected system, with dark matter as the hidden thread weaving everything together. This would change the way we think about not just physics, but existence itself. It would mean that we are not separate from the cosmos but deeply connected to it in ways we have yet to discover. But what does this mean for the future? If we ever develop the ability to manipulate or interact with fuzzy dark matter, it could revolutionize our understanding of the universe. Imagine if we could harness the quantum properties of dark matter to create new forms of energy, new methods of space travel, or even new ways of perceiving reality. If dark matter is linked to the fundamental forces of nature, then controlling it could give us unprecedented control over gravity, time, and even the structure of space itself. And if dark matter is somehow connected to consciousness, then the implications are even more profound. It could mean that the nature of reality is not purely physical but has a hidden quantum dimension that we have yet to explore. It could mean that the boundary between matter and thought, between physics and perception, is not as clear-cut as we once believed. It could mean that our very understanding of reality is still in its infancy, and that the greatest discoveries are still ahead of us. So, what is fuzzy dark matter? Is it simply an invisible wave guiding the structure of galaxies? Or is it something far deeper, a cosmic force shaping not just the universe, but the very nature of existence itself? The truth is, we don't know. But one thing is certain: the more we learn about it, the more it seems like the key to unlocking the greatest mysteries of all. And if we ever find the answers, they might change everything. If fuzzy dark matter is truly a vast quantum wave permeating the universe, then it might be more than just a passive cosmic structure. It might be an active participant in shaping the evolution of everything we know. But how can we even begin to prove something like that? After all, dark matter is called dark for a reason. It doesn't emit light, reflect it, or interact with the electromagnetic forces we rely on for most of our observations. So, if we can't see it, how do we know it's even there? The answer lies in the strange and unexpected ways galaxies behave. If we look at a spinning galaxy, we expect the stars near the center to move faster than the stars on the outer edges, just like how planets in our solar system move faster when they're closer to the sun. But that's not what we see. Instead, galaxies rotate as if they are embedded in an invisible mass, something that holds them together and prevents them from flying apart. The only explanation that makes sense is dark matter, a hidden force accounting for most of the universe's missing mass. But fuzzy dark matter goes one step further. Unlike regular dark matter models that assume dark matter exists as tiny, individual particles, fuzzy dark matter proposes that it behaves as an enormous quantum wave. This changes everything. In a typical dark matter scenario, the universe is filled with tiny, cold, slow-moving particles that barely interact with each other. But in the fuzzy dark matter model, these particles are not just individual dots of mass. They are spread out over vast distances in a wave-like form. This means that instead of acting like a collection of marbles floating in space, dark matter acts more like ripples in a cosmic ocean. These ripples could be responsible for the strange, large-scale structures we see in the universe. Galaxies don't just exist randomly. They are arranged in an intricate cosmic web, stretching across billions of light years. Could fuzzy dark matter be responsible for this? Could the quantum wave nature of dark matter be sculpting the very structure of the cosmos? If that's the case, then fuzzy dark matter isn't just something we need to consider when looking at galaxies. It could be influencing everything, from the formation of stars to the way black holes behave. And here's where things get even weirder. If fuzzy dark matter is truly a quantum phenomenon, then it might be able to do something that defies normal physics. It might be able to interfere with itself. In quantum mechanics, particles don't behave like tiny billiard balls. They behave like waves. And when waves overlap, they interfere with each other, creating patterns of reinforcement and cancellation. If fuzzy dark matter behaves this way, then it could be creating interference patterns on a cosmic scale. This could explain why we see strange, unexplained voids in the universe, regions where galaxies seem to be missing entirely. Could it be that these voids aren't just empty spaces but regions where dark matter waves are canceling each other out? And if that's true, then the universe isn't just a random collection of stars and galaxies. It's a carefully structured system, shaped by forces we are only just beginning to understand. It would mean that space itself is not empty, but filled with an invisible, undulating field that dictates where matter can and cannot exist. It would mean that the fundamental structure of the universe is determined not just by gravity, but by quantum mechanics on a grand, unimaginable scale. But if fuzzy dark matter is doing all of this, then why can't we detect it directly? The problem is that quantum waves are tricky to measure. On small scales, we can observe quantum behavior in particles like electrons and photons. But when quantum effects happen over vast cosmic distances, they become nearly impossible to detect with our current technology. This means that fuzzy dark matter could be all around us, shaping reality in ways we can't yet measure. But what if we could? What if there's a way to detect the ripples of fuzzy dark matter, to actually see it in action? Scientists are already searching for signs of its existence. One of the most promising methods involves looking at the cosmic microwave background, the faint glow left over from the Big Bang. If fuzzy dark matter exists, it would have influenced the early universe in subtle but detectable ways, creating slight distortions in this cosmic radiation. If we can find those distortions, we might finally have proof that dark matter is more than just an invisible substance. It's a quantum force shaping the universe itself. And if we do confirm its existence, the implications are staggering. It would mean that our current understanding of physics is incomplete. It would mean that the universe is not just governed by classical forces like gravity, but by hidden quantum interactions stretching across billions of light years. It would mean that space itself is alive with movement, an endless sea of quantum waves shaping the past, present, and future of everything. And if that's the case, then we have to ask, what else is dark matter capable of? If it can influence galaxies, stars, and black holes, could it also be influencing us? Could dark matter waves be subtly affecting the structure of our own atoms, the electrical signals in our brains, or even the way time flows in our daily lives? Could it be that the mysteries of dark matter are not just cosmic, but deeply personal, woven into the very fabric of our existence? The answers to these questions remain unknown. But one thing is certain: the deeper we look into the mysteries of space, the more we realize that reality is far stranger than we ever imagined. The universe is not a static, lifeless void. It is a dynamic, evolving system, filled with hidden forces and unseen connections. And at the heart of it all might be fuzzy dark matter, a force so fundamental, so pervasive, that it could hold the key to understanding everything. But what happens next? If we do uncover the truth about fuzzy dark matter, what will it mean for the future of science, technology, and even human civilization itself? Could it lead to breakthroughs beyond our wildest imagination, new ways of traveling through space, new forms of energy, or even new insights into the nature of consciousness? Or could it reveal something even more profound, something that forces us to rethink our place in the universe entirely? The search for fuzzy dark matter is only just beginning. And as we continue to explore this cosmic mystery, one thing is certain: the answers we find will change everything. If fuzzy dark matter truly exists as a vast, undulating quantum wave stretching across the cosmos, then it challenges everything we thought we knew about space, time, and even the fundamental nature of reality. It suggests that the universe isn't just a collection of objects floating in empty space but rather a living, breathing structure shaped by invisible forces. But if this quantum wave is real, then how does it behave? What kinds of effects does it have on the universe around us? And could it even influence things on a much smaller, more personal scale? To understand the true impact of fuzzy dark matter, we have to think about how waves behave. In classical physics, waves travel through a medium. Water waves ripple through the ocean, sound waves vibrate through the air. But in the quantum world, waves aren't just disturbances in a medium, they represent probabilities. A quantum wave describes the likelihood of a particle existing in a particular place at a particular time. This means that if fuzzy dark matter is truly a quantum phenomenon, then it isn't just a passive field, it's a dynamic, ever-changing system that determines where matter can and cannot exist. This idea is both mind-blowing and terrifying. It means that the structure of the universe, the arrangement of galaxies, the formation of cosmic voids, even the placement of individual stars, might not be random at all. Instead, it could be dictated by the interference patterns of vast quantum waves stretching across billions of light years. If this is true, then our own existence may not be as accidental as we once thought. The very atoms that make up our bodies, the stars that gave birth to the elements inside us, the black holes that warp space and time, everything could be shaped by the subtle interactions of fuzzy dark matter waves. But if fuzzy dark matter behaves like a wave, then something even stranger might be happening. Quantum waves don't just exist in isolation, they interfere with each other. If fuzzy dark matter truly spans the universe in wave-like forms, then it might be creating interference patterns that influence everything from the movement of galaxies to the behavior of black holes. Could these patterns be responsible for some of the strangest phenomena we've observed in space? Consider the eerie cosmic voids, the massive, empty regions of space where galaxies seem to be missing entirely. These voids are some of the largest known structures in the universe, spanning hundreds of millions of light years. But why do they exist? If the universe were truly random, matter should be more evenly distributed. Yet we see vast stretches of nothingness, separated by dense clusters of galaxies arranged in a complex web. Could it be that these voids aren't empty at all, but rather regions where fuzzy dark matter waves are canceling each other out? If quantum interference is shaping the universe, then the cosmic web we see might be a direct result of these hidden interactions. And what about black holes? These cosmic monsters warp space and time to such an extreme degree that nothing, not even light, can escape their pull. But if fuzzy dark matter is real, then it might be interacting with black holes in ways we never imagined. Could fuzzy dark matter waves be influencing the way black holes form, grow, or even merge? Some scientists speculate that if fuzzy dark matter interacts with black holes, it could create strange effects, perhaps even altering the way time behaves near the event horizon. Could this explain why some black holes seem to have unexpected properties, emitting bursts of energy, or appearing larger than they should be? And then there's the question of how fuzzy dark matter influences the formation of stars. We know that dark matter plays a crucial role in galaxy formation. It provides the gravitational pull necessary for gas and dust to clump together and form new stars. But if dark matter behaves like a wave, then it might be subtly guiding the formation of stars, creating interference patterns that determine where and when new celestial bodies appear. Could this mean that the very stars we see in the night sky, the ones that have guided human civilization for millennia, are arranged not by chance, but by the hidden influence of fuzzy dark matter? But the most mind-bending possibility is this: if fuzzy dark matter is a quantum wave that spans the universe, then it might not just be shaping the large-scale structure of space, it might be influencing the very fabric of reality itself. Quantum mechanics tells us that at the smallest scales, particles can exist in multiple states at once. They can be in two places at the same time, or even communicate instantaneously across vast distances. If fuzzy dark matter is a fundamental part of the universe, then could it be playing a role in these quantum effects? Could it be that the strange behavior of subatomic particles, the randomness, the uncertainty, the bizarre entanglement of quantum states, is actually connected to the vast, hidden waves of fuzzy dark matter? If so, then dark matter isn't just something that exists in the distant cosmos, it's something that permeates our entire reality. It could be affecting everything, from the way atoms bond together to the way time flows in different parts of the universe. It might even mean that space itself isn't truly empty, but filled with an invisible, ever-shifting field of quantum energy. And if that's true, then the implications are staggering. Could fuzzy dark matter be the missing link between quantum mechanics and gravity, the key to understanding the true nature of space-time? Could it explain the mysteries of black holes, the origins of the universe, or even the nature of consciousness itself? Some physicists have even speculated that dark matter might be linked to the very fabric of reality in ways we can't yet comprehend. Could it be that our perception of the universe is shaped, in part, by the unseen influence of fuzzy dark matter waves? The deeper we dive into this mystery, the more it challenges everything we thought we knew. And the more we learn, the more we realize just how much remains unknown. If fuzzy dark matter is real, then it changes everything: our understanding of the cosmos, our place in the universe, and even the nature of existence itself. But the search for answers is far from over. Scientists are racing to find new ways to detect and study these hidden quantum waves, to uncover the truth about their role in shaping reality. And as we push the boundaries of our knowledge, we may find that the greatest mysteries of the universe are not in the distant reaches of space, but woven into the very fabric of our own reality. But what happens if we do uncover the truth? What if we finally prove that fuzzy dark matter is real, that the universe is shaped by vast, hidden waves of quantum energy? What would that mean for the future of science, technology, and even our own understanding of what it means to exist? Could it lead to breakthroughs beyond our wildest imagination, new ways of harnessing energy, new ways of traveling through space, or even new ways of perceiving the world around us? Or could it reveal something even deeper, something that forces us to rethink our entire understanding of reality? One thing is certain: the search for fuzzy dark matter is only just beginning. And as we continue to explore this cosmic enigma, we may find that the universe is far stranger, far more complex, and far more wondrous than we ever imagined. If fuzzy dark matter is real, then it may hold the key to some of the deepest mysteries of the cosmos, including the very nature of gravity. For decades, physicists have struggled to reconcile Einstein's theory of general relativity, which describes gravity as the warping of spacetime, with quantum mechanics, which governs the bizarre behavior of subatomic particles. But if dark matter is a quantum phenomenon, a wave-like entity stretching across the universe, then it may provide a crucial missing link between these two seemingly incompatible theories. One of the biggest puzzles in modern physics is why gravity is so much weaker than the other fundamental forces. The electromagnetic force, for example, is strong enough to hold a tiny magnet to a refrigerator against the gravitational pull of an entire planet. But why is gravity so weak? Some physicists speculate that gravity may not be weak at all, but rather that its effects are being diluted by interactions with hidden dimensions of space or by the presence of an unseen field, perhaps one created by fuzzy dark matter. If this is true, then dark matter isn't just shaping the large-scale structure of the universe, it's actively influencing the fundamental forces of nature. It may be that what we perceive as gravity is actually a side effect of the way mass interacts with the vast, quantum waves of fuzzy dark matter. This could help explain why galaxies don't behave the way we expect them to, why stars at the edges of galaxies move faster than they should, and even why black holes seem to exert such a powerful influence on the fabric of space-time itself. But there's another layer to this mystery. If fuzzy dark matter is truly a quantum field, then it may be connected to the concept of quantum entanglement, the strange phenomenon where particles become linked, such that the state of one instantly affects the state of the other, no matter how far apart they are. Entanglement is one of the strangest and most counterintuitive aspects of quantum mechanics. But what if it isn't just limited to tiny particles? What if fuzzy dark matter itself is an entangled field, stretching across the entire universe? If this is the case, then the implications are profound. It would mean that vast regions of space are connected in ways we can't yet comprehend, that information might be able to travel instantaneously across cosmic distances, and that the very nature of cause and effect might not work the way we think it does. Could this explain why the universe seems so finely tuned for life? Could it mean that everything, every star, every galaxy, every particle, is part of a much larger, interconnected system that operates on a level beyond our current understanding? And if dark matter is connected to entanglement, then could it also be linked to something even more mysterious? Consciousness? Some scientists have speculated that quantum effects might play a role in the workings of the human mind, that consciousness itself may arise from the strange and unpredictable behavior of quantum particles. But if fuzzy dark matter is a fundamental part of the universe, then could it be interacting with the quantum processes inside our brains? Could it be that our thoughts, our perceptions, even our very sense of self, are somehow connected to this hidden, invisible field that stretches across the cosmos? This idea may sound far-fetched, but it isn't entirely outside the realm of possibility. If quantum mechanics governs the smallest scales of reality, and if fuzzy dark matter operates according to quantum principles, then there may be a deeper, hidden connection between the universe and the mind. Could it be that the way we experience reality is shaped, at least in part, by the influence of dark matter? Could this explain certain unexplained phenomena, moments of intuition, sudden bursts of insight, or even the strange feeling of interconnectedness that some people report during profound experiences? And what if fuzzy dark matter isn't just influencing the structure of the cosmos, but also the flow of time itself? We tend to think of time as a straightforward, linear progression from past to future, but quantum mechanics suggests that time may not be as simple as it seems. Some physicists propose that the universe might be fundamentally timeless, with what we perceive as the flow of time being an illusion created by the interactions of quantum fields. If fuzzy dark matter is a quantum field that spans the cosmos, then could it be playing a role in shaping our experience of time? Could it be that the past, present, and future are not as distinct as they seem, but are instead part of a much larger, interconnected reality? And if that's the case, then what happens when we truly begin to understand this mysterious substance? What if future discoveries allow us to manipulate or interact with fuzzy dark matter in new ways? Could we develop technologies that harness its properties, allowing us to access energy from the quantum vacuum, manipulate gravity, or even alter our perception of time? Could understanding this hidden field unlock new forms of space travel, making it possible to move between distant stars without the need for conventional propulsion? Or could it reveal something even deeper, something that forces us to completely rethink our understanding of existence itself? What if fuzzy dark matter isn't just a passive background field, but an active participant in the structure of reality? What if it holds the key to understanding not just the physical universe, but the very nature of consciousness, time, and the fundamental laws of physics? One thing is clear: the search for answers is only just beginning. As scientists continue to explore the mysteries of fuzzy dark matter, they may uncover truths that are even stranger and more profound than we can currently imagine. And in doing so, they may bring us one step closer to understanding the true nature of the universe, and our place within it. If fuzzy dark matter plays a role in shaping the universe in ways we don't yet fully understand, then it might also be responsible for some of the strangest cosmic anomalies ever observed. One of the biggest mysteries in astrophysics is the nature of ultra-diffuse galaxies. Galaxies that appear to have almost no visible matter but still behave as though they contain a massive amount of unseen mass. Traditional dark matter theories struggle to explain why these galaxies exist, but fuzzy dark matter could provide an answer. If dark matter behaves like a wave rather than a particle, then it might create interference patterns that affect how galaxies form, leading to the creation of strange structures that wouldn't be possible under conventional models. And this brings up an even bigger question. If fuzzy dark matter behaves like a wave, then could it be possible for it to form standing waves in space, creating regions where dark matter is more concentrated in some areas and less so in others? This could explain why some galaxies have unusually high amounts of dark matter while others seem to have almost none. It could also mean that dark matter doesn't just passively shape galaxies, it actively determines where they can and cannot form in the first place. But this idea has an even deeper implication. If fuzzy dark matter creates interference patterns across the universe, then it could mean that the structure of the cosmos itself is determined by a kind of cosmic wave function, a hidden, underlying order that we can't directly observe but that dictates the large-scale arrangement of galaxies, voids, and cosmic filaments. And if that's true, then it suggests that the universe isn't just a collection of randomly distributed galaxies, but rather a highly structured and interconnected system, shaped by the strange and invisible properties of fuzzy dark matter. And what if this wave-like behavior extends beyond just the distribution of galaxies? Could it also affect the motion of individual stars, planets, and even black holes? Some astrophysicists have proposed that certain unexplained gravitational anomalies, like the way stars orbit around supermassive black holes at the centers of galaxies, could be a result of interactions with fuzzy dark matter. If dark matter behaves as a quantum field, then it might create subtle but measurable distortions in spacetime, affecting the motion of celestial bodies in ways that don't align with classical physics. And if dark matter is influencing the motion of black holes, then it raises an even more profound question. Could it be possible that fuzzy dark matter plays a role in the creation and evolution of black holes themselves? Some theories suggest that black holes may not be as simple as we think, that they could be surrounded by halos of exotic particles, or even that dark matter itself could collapse under extreme conditions to form entirely new types of black holes that behave differently from the ones we currently understand. And if this is the case, then what does it mean for the nature of spacetime itself? Could it be that the strange properties of fuzzy dark matter allow for the creation of exotic structures like wormholes, shortcuts through spacetime that could, in theory, allow for faster-than-light travel? Some physicists have speculated that if dark matter can exist in a superfluid state, then it might have properties that allow it to form stable, long-lasting wormholes, opening the door to entirely new possibilities for interstellar travel. But if fuzzy dark matter is truly fundamental to the structure of the universe, then its implications go far beyond just astrophysics. It could also be connected to some of the biggest unsolved problems in theoretical physics, including the nature of quantum gravity. For decades, physicists have struggled to unify general relativity, which describes gravity on large scales, with quantum mechanics, which governs the behavior of the smallest particles in the universe. But if dark matter is a quantum phenomenon that operates on cosmic scales, then it might hold the key to bridging this gap. And this brings us to one of the strangest and most controversial ideas in modern physics: the possibility that the universe itself might be a hologram. Some physicists believe that all of the information in the universe might actually be encoded on a lower-dimensional surface, meaning that what we perceive as three-dimensional space might actually be a kind of projection from a deeper, more fundamental layer of reality. And if this is true, then it raises an incredible question. Could fuzzy dark matter be the medium through which this information is transmitted? Could it be that dark matter isn't just an invisible substance filling the cosmos, but rather a fundamental aspect of the way reality itself is structured? And if that's the case, then what does it mean for the nature of consciousness? If the universe is fundamentally quantum in nature, and if fuzzy dark matter plays a role in shaping reality on the largest scales, then could it also have an influence on the way information is processed at the level of the human brain? Some researchers have speculated that consciousness itself might be a quantum phenomenon, and if dark matter interacts with quantum fields in unexpected ways, then it could mean that our very thoughts and perceptions are subtly influenced by this hidden aspect of the universe. Could this explain certain unexplained phenomena, like the feeling of déjà vu, or the sense that time sometimes moves faster or slower than expected? Could it mean that our minds are somehow connected to a larger, hidden system that extends beyond the physical world? And if fuzzy dark matter is truly a quantum wave stretching across the universe, then could it mean that everything, every atom, every planet, every thought, is part of a single, interconnected cosmic field? The deeper we look into the mysteries of fuzzy dark matter, the stranger and more profound the questions become. And as scientists continue to study this elusive substance, they may uncover answers that challenge everything we think we know about the universe, about time, and even about ourselves. If fuzzy dark matter is truly responsible for shaping the universe at a fundamental level, then its implications go even deeper than we've explored so far. What if it's not just a passive, invisible scaffolding for galaxies but an active force that interacts with matter in ways we don't yet understand? What if the very laws of physics that govern our universe are shaped by its presence? This leads us to one of the most mind-bending ideas in theoretical physics. Could fuzzy dark matter be linked to the fabric of spacetime itself? For years, scientists have searched for a quantum theory of gravity, a way to merge Einstein's general relativity, which describes gravity on a cosmic scale, with quantum mechanics, which governs the tiniest particles in existence. But the two theories seem to contradict each other in key ways. General relativity treats space and time as smooth and continuous, while quantum mechanics suggests that at the smallest scales, reality is made up of discrete, probabilistic interactions. If fuzzy dark matter is truly a quantum wave existing on galactic scales, then could it serve as the missing link between these two theories? Some physicists have proposed that dark matter might not just exist within spacetime but could be a fundamental aspect of spacetime itself. This would mean that rather than being a separate, invisible substance, it could actually be woven into the very structure of the universe. If this is true, then it might explain why we've had such a hard time detecting dark matter as individual particles. It isn't separate from space, but an intrinsic part of it. And if that's the case, then it raises an incredible question. Is space itself a quantum field, shaped by the wave-like properties of fuzzy dark matter? This idea could also explain some of the most puzzling cosmic phenomena, like the way galaxies rotate. In the standard dark matter model, dark matter acts as an invisible halo surrounding galaxies, providing the extra gravity needed to hold them together. But if dark matter is instead a fundamental aspect of spacetime, then it might mean that the laws of motion themselves are different at large scales. It could mean that gravity itself behaves differently in regions of high dark matter density, not because of extra mass, but because of how spacetime bends and warps in the presence of fuzzy dark matter waves. And if that's true, then could it also affect time? Einstein's theory of relativity tells us that time is not absolute. It stretches and compresses depending on gravity. If fuzzy dark matter creates large-scale gravitational effects, then could it also create variations in time itself? Could this explain why time appears to move differently in different parts of the universe? Or why certain cosmic structures seem to evolve at unexpected rates? Some researchers have speculated that dark matter might even play a role in the mysterious force known as dark energy, the unknown phenomenon that is causing the universe to expand at an accelerating rate. Traditional theory suggests that dark energy is an entirely separate force from dark matter, but what if they're actually two sides of the same coin? If fuzzy dark matter behaves as a quantum wave, then it could generate effects that mimic dark energy, creating repulsive forces that push galaxies apart. This could mean that rather than being two unrelated mysteries, dark matter and dark energy are actually part of a single, unified framework, one that we've only just begun to understand. And this raises a question that goes beyond physics. if dark matter and dark energy are deeply connected, then what does that mean for the fate of the universe? Will these forces continue to shape the cosmos in the same way forever, or could they evolve over time? Some theories suggest that dark energy could eventually overwhelm dark matter, leading to a future where galaxies are ripped apart by an ever-accelerating expansion. Others propose the opposite, that dark matter could eventually condense and collapse, pulling the universe back together in a massive, big crunch. But what if there's a third possibility? What if fuzzy dark matter, with its wave-like properties, allows for a cyclical universe, one that expands and contracts in an endless cycle, driven by the fundamental quantum nature of dark matter itself? Some theories suggest that quantum fields can reset over time, meaning that instead of a single beginning or end, the universe might go through infinite cycles of birth, evolution, and rebirth. If fuzzy dark matter is responsible for this process, then it could mean that the universe is not just a one-time event, but an eternal, self-renewing system. And if that's true, then what does it mean for life? Could it be possible that intelligent life has emerged before, in previous cycles of the universe, only to be wiped out and reborn again? And if dark matter plays a role in shaping the evolution of galaxies, then could it also influence the conditions necessary for life to emerge? Some scientists have speculated that dark matter might have even played a role in the formation of planets and the chemistry of early life. If fuzzy dark matter creates regions of varying gravitational strength, then it could have subtly influenced the way matter clumped together in the early universe, leading to the formation of stars, planets, and even the complex molecules necessary for life. This raises an incredible possibility. What if fuzzy dark matter isn't just shaping the universe on a cosmic scale, but also playing a hidden role in the evolution of life itself? And if dark matter has influenced the evolution of life, then could it also be responsible for some of the deepest mysteries of human consciousness? Some researchers have proposed that the brain might operate using quantum principles, meaning that our thoughts and perceptions could be tied to the same fundamental forces that govern the cosmos. If dark matter interacts with quantum fields, then could it mean that our own minds are subtly influenced by the unseen waves of fuzzy dark matter? Could this explain some of the strangest phenomena reported throughout history, like unexplained feelings of déjà vu, sudden intuitive insights, or even altered states of consciousness? If dark matter is truly a quantum wave extending across the universe, then could it be possible that consciousness itself is part of a larger, interconnected system, one that stretches beyond the limits of what we currently understand? The more we learn about fuzzy dark matter, the more it challenges our understanding of the universe, of time, and even of ourselves. It forces us to question the very nature of reality, pushing us toward deeper and more profound questions. What if dark matter isn't just an invisible force acting on galaxies, but the very foundation of existence itself? And if that's the case, then how much of what we think we know about reality is actually just an illusion, shaped by forces we've only begun to comprehend? If fuzzy dark matter is truly woven into the fabric of the universe itself, then the implications stretch far beyond just physics. It challenges our fundamental assumptions about space, time, and even existence itself. Could this strange, ghostly substance be the missing ingredient that unifies all forces in nature? Scientists have long searched for a theory of everything, a single framework that ties together gravity, electromagnetism, and the quantum forces that govern the subatomic world. But every attempt so far has hit a roadblock. General relativity describes gravity as the bending of space-time, while quantum mechanics describes reality as a chaotic sea of probabilities. These two frameworks don't fit together. But what if the problem is that we've been missing a crucial component, something that links the macroscopic and microscopic worlds together? This is where fuzzy dark matter might come in. Unlike other dark matter candidates that behave like individual particles, fuzzy dark matter acts like a vast, cosmic wave, stretching across galaxies. This wave-like behavior is strikingly similar to quantum fields, the fundamental entities that give rise to all known particles. In fact, some researchers speculate that fuzzy dark matter could be a type of hidden quantum field, one that exists on scales much larger than anything we've studied before. If this is true, then it could mean that the laws of quantum mechanics don't just apply to tiny particles but to the entire universe itself. This idea could also help explain another mystery: why the structure of the universe appears so finely tuned for life. If the constants of nature, things like the strength of gravity or the charge of an electron, were even slightly different, galaxies wouldn't form, stars wouldn't shine, and planets capable of supporting life wouldn't exist. Some scientists propose that this fine-tuning is just a coincidence, or that we happen to live in a multiverse where countless other universes exist with different physical laws. But what if the answer lies in fuzzy dark matter? Some theories suggest that dark matter could act as a kind of cosmic stabilizer, subtly influencing the fundamental constants of nature. If fuzzy dark matter is linked to the structure of spacetime, then it might not just determine the motion of galaxies, it might also shape the very laws of physics themselves. This would mean that the universe isn't fine-tuned by chance, but by the hidden influence of an invisible force. But if fuzzy dark matter is truly this fundamental, then it raises an even deeper question: has it always existed, or could it evolve over time? Most cosmologists assume that dark matter has been around since the beginning of the universe, created in the aftermath of the Big Bang. But what if fuzzy dark matter, like everything else in the cosmos, is subject to change? Could it be possible that the nature of dark matter itself has shifted throughout cosmic history, subtly altering the way galaxies form and evolve? This idea might help explain why the universe looks different at different points in time. When we look at distant galaxies, we're actually seeing them as they were billions of years ago, since light takes time to travel across space. And one of the great mysteries of cosmology is that early galaxies seemed to behave differently than those we see today. Some researchers believe this could be due to changes in dark matter. If fuzzy dark matter is a quantum wave, then it's possible that its properties could shift over time, just like other quantum systems. And if dark matter can change, then could it also be influenced by external forces? Could interactions with normal matter or even radiation alter its behavior? Some scientists have proposed that dark matter might be affected by cosmic events like supernova explosions or black hole mergers. If this is true, then it could mean that fuzzy dark matter isn't just a passive background force. It could be part of an ongoing, dynamic process that shapes the universe in ways we've never imagined. But here's where things get really strange. If fuzzy dark matter is a quantum field that spans the universe, then could it also store information? In quantum mechanics, information is never truly lost. Even when particles interact and change form, the underlying information about their states remains encoded in the fabric of reality. If fuzzy dark matter behaves like a quantum wave, then could it act as a kind of cosmic memory, a vast, hidden record of everything that has ever happened in the universe? This idea might sound far-fetched, but it's not entirely outside the realm of physics. Some researchers have suggested that black holes, for example, could function as information storage systems, encoding details about everything that falls into them. If dark matter plays a similar role on a much larger scale, then it could mean that the universe itself contains a kind of built-in record of its own history. And if dark matter holds information, then could it also play a role in consciousness? This is one of the most speculative but intriguing possibilities. Some physicists have proposed that the human brain operates at least partially on quantum principles, meaning that thought itself might be tied to deeper physical processes. If fuzzy dark matter is a universal quantum field, then could it somehow interact with the mind? Could this explain certain unexplained phenomena, like intuition, creativity, or even a sense of connection to the cosmos? This idea might seem outlandish, but it wouldn't be the first time that an invisible force turned out to have profound effects on reality. For most of human history, people had no idea that electromagnetism existed, even though it governs everything from light to brain activity. What if fuzzy dark matter is another fundamental force, one that we're only just beginning to recognize? And if that's the case, then what else could it be responsible for? Could it explain why galaxies form the way they do? Could it be the reason why time flows in one direction instead of another? Could it even be the key to understanding the origin of the universe itself? The more we investigate fuzzy dark matter, the more it seems to challenge everything we thought we knew. It's not just a missing piece of the cosmic puzzle, It might be the puzzle itself, a force that underlies reality in ways we've yet to comprehend. If fuzzy dark matter is truly this fundamental, then it could mean that the very structure of the universe is dictated by an invisible, omnipresent quantum field. But if that's the case, how does it actually work? What rules does it follow? And more importantly, how do we prove that it exists? This is where things get tricky. Unlike normal matter, which interacts with light and other forces, fuzzy dark matter is, by definition, practically undetectable through traditional methods. It doesn't emit, absorb, or reflect any known form of radiation. We can't see it, we can't touch it, and we can't trap it in a lab. All we can do is study its effects on the universe at large and look for clues hidden in the way galaxies behave. One of the biggest pieces of evidence for fuzzy dark matter comes from the unusual motion of stars within galaxies. Normally, you'd expect stars to orbit the galactic center at speeds that decrease the farther out you go, kind of like how planets in our solar system move slower the farther they are from the sun. But that's not what we see. Instead, the stars at the edges of galaxies are moving just as fast as the ones closer to the center. This makes no sense under standard physics. The only way to explain it is if there's some invisible mass holding everything together, dark matter. But the question is, what kind of dark matter? If dark matter were made of heavy, slow-moving particles, as some theories suggest, we'd expect to see small-scale clumps of it scattered throughout galaxies. But we don't. Instead, galaxies appear to have smooth, evenly distributed halos of dark matter surrounding them. And this is where fuzzy dark matter starts to make sense. Because it behaves like a quantum wave rather than individual particles, it naturally forms these smooth, diffuse structures, matching what we actually observe in space. But it gets even stranger. Some galaxies, particularly small dwarf galaxies, exhibit behaviors that don't quite fit with conventional dark matter models. These galaxies should have tightly packed cores of dark matter at their centers, but in reality, their cores appear to be much more spread out. This is exactly what you'd expect if dark matter had wave-like properties. Just like how sound waves can interfere with each other to create patterns of high and low intensity, fuzzy dark matter waves could interfere to create regions of higher and lower density in galaxies. This interference could be the reason why some galaxies have diffuse cores instead of dense ones. And here's the wild part. If fuzzy dark matter really is behaving like a wave, then it should also produce observable ripples on cosmic scales. These ripples wouldn't be visible as light, but they could affect the distribution of galaxies throughout the universe. Some astronomers are already looking for these patterns, scanning large-scale galaxy surveys for hints of wave-like structures in the cosmic web. If they find them, it could be one of the strongest pieces of evidence yet that fuzzy dark matter is real. But even if we confirm its existence, we still have another problem. Where did it come from? If fuzzy dark matter has been around since the beginning of time, then it must have played a role in shaping the early universe. But how? Standard dark matter theories suggest that dark matter clumped together first, providing the gravitational scaffolding that allowed normal matter to form galaxies. But if fuzzy dark matter is more like a quantum field, then its role in cosmic evolution might be even more profound. Some researchers speculate that fuzzy dark matter could have influenced the very structure of space itself. In the earliest moments after the Big Bang, the universe was a chaotic, high-energy soup of particles and radiation. But as it expanded and cooled, the fundamental forces of nature began to take shape. If fuzzy dark matter existed at this time, its wave-like nature could have acted as a kind of stabilizing force, guiding the formation of galaxies and clusters in ways we don't yet fully understand. And if that's true, then it could mean that fuzzy dark matter is more than just a missing piece of the cosmic puzzle. It could be the key to understanding why the universe looks the way it does. It might even be linked to the mysterious force known as dark energy, which is driving the accelerated expansion of the universe. Some theories suggest that dark energy and dark matter are two sides of the same coin, different manifestations of a deeper, hidden structure in space-time. If that's the case, then understanding fuzzy dark matter could bring us one step closer to solving one of the biggest mysteries in all of physics. But here's where things get really weird. If fuzzy dark matter is a fundamental part of the universe, then could it also play a role in time itself? One of the strangest aspects of quantum mechanics is that time doesn't behave the way we expect it to. At the smallest scales, quantum systems don't experience time in a linear way. Instead, past, present, and future can blur together in strange and counterintuitive ways. If fuzzy dark matter is a quantum field that permeates the entire universe, then could it somehow be linked to the nature of time? Some physicists have proposed that time might not be a fundamental property of reality at all. Instead, it could emerge from deeper, hidden processes that could be connected to the strange, wave-like nature of dark matter. If this is true, then it could mean that fuzzy dark matter isn't just shaping space. It could be shaping time itself. And if that's the case, then what else could it be capable of? Could it hold the answers to some of the deepest questions about existence? Could it explain the origin of consciousness? Could it be the key to unlocking new forms of energy, or even new ways of manipulating reality? The more we learn about fuzzy dark matter, the more it challenges everything we thought we knew about the universe. It's not just an invisible force, it could be a fundamental, hidden layer of reality, one that we're only just beginning to uncover. If fuzzy dark matter is more than just a missing component of the universe, if it's actually a deeper layer of reality that we've barely begun to understand, then what does that mean for physics as we know it? Could it mean that we've been thinking about the universe all wrong? For decades, physicists have been trying to unite the fundamental forces of nature under one grand theory, a single framework that explains everything from gravity to quantum mechanics. But so far, we haven't been able to do it. Gravity, which works on the largest cosmic scales, doesn't fit neatly into the equations of quantum mechanics, which govern the smallest particles. These two realms, cosmic and quantum, seem almost like separate realities that refuse to be reconciled. But what if fuzzy dark matter is the missing link? If it's truly a quantum wave field that spans the universe, then it could act as a kind of bridge between these two worlds. Unlike traditional dark matter theories, which treat dark matter as heavy, invisible particles, fuzzy dark matter suggests that the universe has an underlying wave-like structure. And if that's the case, then maybe space and time themselves are not what we think they are. Consider this: if space is filled with an invisible, oscillating quantum field of fuzzy dark matter, then what we perceive as empty space isn't actually empty at all. Instead, it's a vast, shifting ocean of quantum waves, constantly interfering, interacting, and shaping the universe in ways we can't yet see. This would mean that gravity isn't just the warping of spacetime, as Einstein described. It could also be influenced by the properties of this hidden, vibrating field. If true, this could bring us closer to a quantum theory of gravity, something physicists have been chasing for over a century. But the implications don't stop there. If fuzzy dark matter is a wave-like field that stretches across the entire universe, then it could also be connected to another great cosmic mystery: black holes. Black holes are already strange enough on their own. They bend space and time so severely that not even light can escape their pull. But recent discoveries have suggested something even stranger. The area around black holes may not be empty but could instead be filled with a mysterious, unseen substance. Could this substance be fuzzy dark matter? Some physicists believe that black holes might be surrounded by fuzzy halos of dark matter, where the quantum wave nature of this substance creates strange, ghostly structures. Unlike the smooth, featureless event horizon we usually imagine, these halos could contain rippling patterns, shifting densities, and even vortex-like structures created by interference in the quantum wave field. If that's true, then it could mean that black holes are not just gravitational traps but also key sites where the fundamental nature of fuzzy dark matter is revealed. And then there's the question of how fuzzy dark matter interacts with time itself. If dark matter behaves like a vast quantum wave, then could it influence the way time flows? In standard physics, time is usually treated as a simple, one-directional dimension, something that moves forward at a steady rate. But in quantum mechanics, time isn't so simple. Quantum particles don't experience time in the way we do. Instead, they exist in states of superposition, where past and future can blur together. If fuzzy dark matter is a quantum field that stretches across the universe, then could it somehow be entangled with the flow of time? Some physicists have suggested that time itself might emerge from deeper quantum processes, meaning that what we experience as past, present, and future could be illusions created by an underlying quantum structure. If that's the case, then fuzzy dark matter could be more than just an invisible force holding galaxies together. It could be a fundamental aspect of time itself. But perhaps the strangest possibility of all is this: if fuzzy dark matter is a universal quantum field, then could it have something to do with consciousness? Some radical theories in physics suggest that consciousness might not just be a product of the brain, but could instead be linked to the fundamental structure of reality. If fuzzy dark matter is a vast, omnipresent quantum field that pervades the universe, then could it somehow be connected to the way we experience reality? Could it be the missing link between the physical world and the mysterious nature of consciousness? It's a mind-bending idea, but it's not as far-fetched as it sounds. Some theories of quantum mechanics suggest that consciousness itself may be a quantum phenomenon, arising from the strange, non-local interactions of quantum waves. If that's the case, then maybe our own thoughts and perceptions are not entirely separate from the quantum nature of the universe. Maybe the fabric of reality itself is intertwined with the very thing that allows us to perceive it. And if that's true, then what does it mean for the future of physics? What if fuzzy dark matter isn't just a missing piece of the puzzle but the key to understanding everything? The nature of space, time, gravity, black holes, and even the mind? If fuzzy dark matter is more than just an invisible force shaping galaxies, if it's truly a fundamental part of reality, then the implications go beyond physics. They could touch the very nature of existence itself. For centuries, humans have tried to answer the most profound questions: what is the universe made of? What is our place in it? And ultimately, why does anything exist at all? If fuzzy dark matter turns out to be a universal quantum field, then it could provide new insights into these age-old mysteries, challenging everything we think we know about the cosmos. One of the strangest aspects of fuzzy dark matter is its connection to the concept of wave functions. In quantum mechanics, particles don't exist in definite positions until they are measured. Instead, they exist as probability waves spread out across space, only collapsing into a specific location when observed. If fuzzy dark matter behaves like an enormous quantum wave, then could the entire universe itself exist in a kind of quantum superposition? Could reality, as we know it, only emerge when observed? This idea isn't just science fiction. Some interpretations of quantum mechanics, such as the Copenhagen interpretation, suggest that observation plays a fundamental role in shaping reality. If fuzzy dark matter is a quantum field that spans the universe, then it might interact with this process in ways we don't yet understand. Perhaps dark matter isn't just a passive force, it might be an active participant in the structure of reality, influencing how matter, energy, and even consciousness emerge. And if that's the case, then what does it mean for the concept of parallel universes? Some physicists believe that the quantum world doesn't just allow for different possibilities, it creates them. Every time a quantum decision is made, an alternate reality could branch off, leading to a vast multiverse of possibilities. If fuzzy dark matter is a quantum field that pervades everything, then could it be the medium that connects these parallel realities? Could it be the fabric that links different timelines, different histories, and different versions of the universe? There's another possibility, one that's even more unsettling. What if fuzzy dark matter is evidence that our reality is not as solid as it seems? If the universe is filled with an invisible, oscillating quantum wave field, then could it mean that space itself is not continuous, but pixelated, like a digital simulation? Some physicists have speculated that reality might function like a vast computational system, where what we perceive as space and time are actually emergent properties of a deeper, more fundamental code. If that's true, then fuzzy dark matter might not just be a missing component of physics. It could be a glitch, a clue that the fabric of reality itself is programmed. And here's the truly mind-bending part. If fuzzy dark matter is a universal quantum field, then could it be manipulated? Quantum fields can interact with each other, influence matter, and even be shaped by energy. If we ever learn to control fuzzy dark matter, then could we unlock new forms of technology beyond anything we can currently imagine? Could it allow us to manipulate gravity, warp space-time, Or even tap into the hidden energy of the cosmos? This isn't just wild speculation. Scientists are already experimenting with quantum fields, using high-energy physics to probe the nature of the vacuum. If fuzzy dark matter is real, then it might be possible to detect its effects, and eventually, even harness them. The implications would be staggering, revolutionizing space travel, energy production, and even our understanding of consciousness itself. And if that's the case, then what does it say about the nature of life? If the universe is filled with a quantum wave field that influences space and time, then could it also play a role in the emergence of life itself? Some scientists have proposed that quantum processes may be involved in biological evolution, guiding the development of complex organisms. If fuzzy dark matter interacts with the fundamental structure of the universe, then could it have played a role in the formation of life on Earth? Could it be a hidden force that shaped the very existence of consciousness? We don't have the answers yet. But the more we learn about fuzzy dark matter, the more it challenges our understanding of reality. It's not just an abstract concept, it's a key that could unlock the deepest secrets of the universe. And as we continue to explore this mystery, we might discover that the cosmos is far stranger, more complex, and more interconnected than we ever imagined. If fuzzy dark matter is truly a quantum wave field that permeates the universe, then it raises an even deeper question. Is it possible that we've been looking at the structure of reality in entirely the wrong way? For centuries, science has operated under the assumption that the universe is made of discrete, separate objects, particles, planets, stars, and galaxies, all following predictable laws of motion. But what if the fundamental nature of the cosmos isn't about separateness, but interconnectedness? What if everything we see, from the smallest particles to the largest cosmic structures, is actually part of one vast, vibrating field? This idea isn't as far-fetched as it might seem. In quantum physics, fields are more fundamental than particles. What we call particles are really just localized excitations of underlying quantum fields. Electrons, photons, and even quarks, the building blocks of matter, aren't tiny solid objects, but disturbances in invisible fields that extend throughout space. If fuzzy dark matter is real, then it could be one of these fundamental fields, shaping the universe in ways we've barely begun to understand. And if that's true, then could it mean that space itself isn't as empty as we once thought? Traditional physics tells us that outer space is a vast vacuum, devoid of matter except for the occasional particle drifting through the void. But if fuzzy dark matter is a quantum wave field, then empty space might not be empty at all. It might be filled with an unseen, oscillating energy that influences everything around it. This could explain why galaxies rotate the way they do, why cosmic structures form the patterns they do, and even why the expansion of the universe behaves so strangely. But if space is filled with this invisible energy, then could it be manipulated? Scientists have long speculated about the possibility of manipulating the quantum vacuum, the underlying energy that exists even in empty space. Some theories suggest that if we could learn to control quantum fields, we might be able to create entirely new forms of propulsion, allowing spacecraft to travel vast distances without the need for traditional fuel. If fuzzy dark matter is a quantum field that pervades the universe, then could it be the key to unlocking new, physics-defying technologies? Could it allow us to harness an energy source beyond anything we've ever known? And if we could manipulate it, then what would that mean for our understanding of gravity? Gravity is the weakest of the four fundamental forces, yet it has the most influence on the large-scale structure of the universe. Unlike electromagnetism, which can be controlled with technology, or the nuclear forces, which we've learned to harness for energy, gravity has remained elusive. We can measure it, we can predict its effects, but we have no way to truly control it. But what if fuzzy dark matter plays a role in gravity that we haven't yet discovered? Some physicists believe that if dark matter is truly a quantum field, then it could interact with gravity in ways that defy our current understanding. It might even be possible that the reason we can't unify gravity with quantum mechanics is that we've been missing a crucial piece of the puzzle, an invisible, universe-spanning field that links these two realms together. If we could understand this connection, then it might lead to the greatest breakthrough in physics since Einstein's theory of relativity, a true, quantum theory of gravity. And that brings us to the biggest mystery of all. What does this mean for the nature of reality itself? If the universe is not just a collection of objects moving through space, but rather a vast, interconnected wave field, then could it mean that our perception of reality is just an illusion? Could it mean that what we experience as solid matter, as time, as existence itself, is really just a projection of deeper quantum processes? Some scientists have suggested that the universe may be a kind of hologram, where the three-dimensional world we experience is actually a reflection of a deeper, two-dimensional quantum structure. If fuzzy dark matter is a universal quantum field, then it could be the medium through which this holographic reality emerges. It could be the hidden fabric that underlies everything we see, shaping the world in ways we don't yet understand. And if that's the case, then what does it say about consciousness? Could our thoughts, our perceptions, and even our sense of self be linked to this hidden quantum field? Could the strange, wave-like nature of fuzzy dark matter somehow play a role in the way we experience reality? Some physicists have speculated that consciousness itself may be a quantum phenomenon, arising from the same kinds of wave functions that govern particles at the smallest scales. If that's true, then it could mean that our minds are not separate from the universe, but deeply connected to it at a fundamental level. If fuzzy dark matter turns out to be real, then it could change everything we know about the universe. It could rewrite the laws of physics, reshape our understanding of space and time, and even challenge the way we think about reality itself. And as scientists continue to search for answers, we may soon find that the greatest mystery of all isn't just out there in the cosmos. It's woven into the very fabric of existence itself. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.